Okay. Okay, well, sorry about that. I just hit the wrong button. Yeah, so we founded Geoengineering Free Canada a few years back, actually, because we were like everyone else, kind of, we noticed the lines in the sky and we thought, okay, well, we need to do something about it. But we soon found out that there is much more to it than just what we see up in the skies here. We did a lot of research. We found a website called ClimateViewer.com. We got in touch with Jim Lee, and since then, and I'm very, very honored to say that we became friends since then. We soon, however, found out that geoengineering is far more complex and sometimes even more complicated than what's going on in our skies. So throughout our journey, we met our tonight's featured guest and friend, Jeff, the weather guy. Jeff taught us a lot about the weather and what to consider while looking up in the skies. Why do we sometimes see the trails and why next day we don't? And how does this fit into geoengineering? Before we get into our session, let me tell you, it's an open Q&A. Please feel free to leave your mics open and get into our conversation with our guest and the ClimateViewer gang. Jeff, kindly introduce yourself. And before we get started, just please make sure when you leave your mics open that there is no background noise so that we don't have a kind of an acoustic feedback. That would be much appreciated. But anyway, so now, Jeff, kindly introduce yourself and we get started. The floor is yours.
Right there. There we go. I should be there now, right?
Yes, we can hear you.
Okay. Stella's been working with me on this stuff for a long time, and I'm starting to get things right. So, anyway, I was in the Navy for 8 years as a weather observer and then a forecaster. So in that process, I was briefing pilots on the weather, what they would expect during their flights. We were their last stop. We launched radiosondes to assess the weather. We plugged in all that data into software programs for the Navy, and that would help you determine how far radar could see so that you could evade the enemy. So you would know how far you could see the enemy with radar, and sonar as well. Same thing for under the water. So I was a forecaster for the weather station, had to do the warnings for the weather station. And anyway, wore a lot of hats during those 8 years. And then I picked it up again a couple of years ago when it was time to start looking at contrails and chemtrails. So got back into it pretty heavily about 3 years ago. I think that kind of covers it. Met all you guys on Jim Lee's group. Met Jim like a year and a half ago and hit it off with him really well. And it's just been fun here being with this group and trying to get the truth.
Yeah, we are trying to find the truth and to get the truth out to the public. So like I say, everybody, you can certainly, please feel free to unmute. So ask questions. This is an open discussion. This is why we call it a Q&A session, because we don't want to present all the time. We want you to ask the questions. We want to interact with you, and we want to hear what your questions are, and that is important to us. Please feel free to ask. Well, my first question, if you don't mind me, then I start with one question I have. What is an ISSR, Jeff?
Ice supersaturated region. So it's a part of the atmosphere that floats in from the west, and it's a moisture-rich area where it's really cold, and that gives you perfect conditions for contrails. So sometimes it's large. I mean, it might cover the area of several states. like I've seen it be, California, Washington, Oregon, that large. So, several thousand square miles. And you'll see the contrails form in the morning, and then they spread out, they hit the tropopause, they spread out, and you'll see the skies just fill with them, of persistent contrails turning into cirrus clouds and cirrostratus by afternoon. So that's a ISSR, ice supersaturated region.
Okay.
I could show you the screen right now and look for one.
Yeah, hang on. I'll make you co-host and then you can share your screen. 1 second.
Okay.
Okay, go ahead.
Okay, so, I just got rid of that screen. Hold on 1 second. I gotta get that back. So I can zoom. Uh-oh, wrong one. Okay, no laughing, Stella. What did I do with it?
So you need to go down to share screen. You see that green arrow pointing up?
I got rid of that screen.
Okay, go back in. Okay, go back into your Zoom
Here we go.
screen.
Okay.
Okay, and then
share. I found it.
Yeah.
Got rid of the screen before I did the share, so that
Right.
doesn't help.
Right.
And desktop share. Okay. Can you see that?
Yes, we can. We can see the Zoom right now, and then yes. Okay, go ahead.
Okay. So I've put this on a product called Ramb Slider, and I gave some links earlier, so I'm not going to be able to drop the stuff in chat very easily. So this one is the West Coast. I'm looking there first. So I'm going to set this on a product called Dust UMETSAT, and it gives you a perfect look at contrails. So you have one forming right there. That's a ISSR right there. You can see all the jet contrail streaks in that cloud shield. This red area right here, it's still loading, but it's got a legend at the bottom. And as soon as that comes up, it's going to show you that the red is high, thick, there we go, cold, thick clouds. And then you got blue, very thin clouds. Mid thick clouds are yellow, which are like middle of the atmosphere, like 10 or 15,000 feet. And you can see the jet trails just jump out in that thin southern edge of the cloud shield. That's where you'll usually find them. Southern and eastern edges of cloud shields. You can see that extends down to, it's going to be in Southern California in a couple hours. So there's one right there. And you could tell by the cloud patterns right here, you could see that there's like a bump. That highlights a ridge. That's a high pressure ridge, which means good weather. So whenever you see that bump on the northern hemisphere, southern hemisphere, it'll look like a U. It's upside down. Everything down there is opposite as up here. You can see here's a low pressure center. So the jet stream always comes south of a low, and then it goes along that ridge line. So the jet stream is going in that same fashion. So where you typically find them is in a ridge, you have descending air, so it melts, evaporates all your clouds down low, and gives you a clear view of the skies. If I were to go outside right now, I live near Sacramento. I guarantee you I'd see a whole bunch of contrails out there moving from the northwest to the southeast. So just for the fun of it, let's look somewhere else. Here's
Jeff, can I quickly interrupt you because there is a question maybe that
yes.
is something.
Yes.
Yeah.
Sure.
Okay, Troy, go right ahead.
Yeah, can you hear me?
Yes.
I can.
Hear you.
Yeah, so I'm on the east coast of Canada.
Hmm.
So 95% of the time when we're right on the high traffic for the jets. And so today there was lots of contrails in the sky. And 95% of the time that we see a lot of contrails in the sky, we end up with rain the next day or the day after. And so our
Yes.
forecast, or they're forecasting rain on Sunday night or coming Monday. And so I was just wondering, like, what's the correlation like out there right now? It's hazy because of all the contrails that were out all day today. And so I'm
Okay.
just wondering, is what is the correlation between that, and if you could have a look at the East Coast.
Okay. I have the East Coast up right now. Can you see
See
that?
that? Yep.
Okay, so you got a low pressure center up near the Hudson Bay, just south of the Hudson Bay. That's the center. You can see the spiral right there.
Yeah.
Ahead to the east, you have a warm frontal cloud band, which is where you have warm air replacing the cold air. And that's a long sloped surface. So you have, I should have grabbed a picture of the type of clouds that you get. So I'll just draw a picture in your mind. Picture a long slope surface from lower left to right. The cold air is, or the warm air is coming from the right and riding up over the cold air. So you have really, really high, thin cirrus clouds first, and then they get thicker as that front moves towards you. So then they get cirrostratus and then altostratus, and then the sun disappears. You lose the halo after the cirrostratus is what you see when you get that halo. And then as the clouds get thicker and lower, that becomes altostratus, nimbostratus. And then you get closer to the front, you have steady rain at that point. So right here, you could see across the Hudson Bay is the leading edge of that cloud band. And if I zoom in, at the very leading edge, I can probably pick out some contrails there. There's some. You could see the blue up off of Nova Scotia, St. John's.
Yeah. Yeah.
So those were farther east in the morning, and it's, or rather farther to the west, and you can see the clouds are moving from west to east, which they always do. It could be southwest to northeast, or it could be northwest to southeast. In this case, they're moving northwest to southeast. So every one of those blue streaks is a contrail. And, 500 miles per hour, it goes and comes and goes. These are 10 minutes apart, each of these pictures. No, I have it set for 30. I'm not going to mess with that, but you can get them as often as 10 minutes or up to, 960 minutes apart between the satellite pictures. So I'll leave it at 30 because it's good enough for now, but you can get tighter spacing on the time frame if you want. So the contrails are a symptom of what's coming already. And they're at the leading edge because that's the thinnest clouds where you can see them by both satellite and by eye. And as it gets thicker, when you get into this darker, the reds,
Yeah.
that's your cold, thick clouds. You lose them because it's thick and the contrail becomes part of the cloud. You just can't see it from satellite um, or by eye. But in this case, if you look here, right up here, where I got my thing right here, you can see those jets are probably right above the cloud shield, so they're still showing up, even though it's in that thick area. So that's telling me that the jets are right above that cloud layer. They don't like flying in cloud usually because you can get the bumpiness in the clouds. So, and I think they like to have visibility. So they pop above the clouds. They request from air traffic control, request 1,000 feet higher to get out of cloud.
Hey,
So,
Jeff.
yeah.
This is Renette. I'm only here for a few minutes. We have a dinner going on with friends, but I want to say hi to everybody. I love that you guys are doing this. One of the things you explained to me was that when a storm is coming in, essentially it's ahead of the storm front and the big storm clouds. It's pushing moisture, and that's one reason why we're more likely to see, these persistent contrails, because generally in the geoengineering in the chemtrail world, people are saying, "Oh, look at they're chemtrailing today because the storm is coming in, so they're spraying us, so it'll come out, in the precipitation." But really, what's happening is there is a moisture band in front of the big storm clouds, and which really makes the atmospheric conditions just ripe for us to see those persistent contrails. Is that correct?
That's correct. So
Okay.
your bad storm stuff is back here with the closer to that low, or the cold front coming to the southwest. That's where I mean, you got severe weather in this part of the world now through Tennessee and whatnot. Bad thunderstorms happening and all that, where this really southward extending band from that low. So yeah, the bad weather is still coming. This is the leading edge of the cloud band, and those contrails are a symptom of what is coming, not causing anything.
Mm-hmm.
Doesn't make sense to geoengineer if it's going to rain out, does it?
Exactly.
What's up,
It's
Jay?
coming.
How's it going, Jay?
That's me. Yeah.
Cool to see you here, man.
Mr. Jim.
Mr. Jeff.
Hi, Jay. Nice to meet you. We saw you first yesterday.
Hello, hello. I decided to get on tonight.
Wonderful. Thanks for joining us. And now the
Nice to meet
Climate
you.
Viewer gang is completed, by the way.
I'm getting ready to hit the go live button, so I'm sorry I'm late, but that's what I normally do. So yeah, I'm trying to set up the restream right now. I'm just gonna hit go live and see what
Well,
happens.
I'm gonna say, you guys, hello. I'm sorry I can't join you. I did want to jump on and say hello. So I hope, are you guys gonna do this kind of regularly? Are you planning
Yes.
on doing?
Yes, Renette,
Yes.
do these calls regularly.
Fantastic. Fantastic. I want to do the next round, the full round. So great to see all of you, and I look forward to the next round.
Sounds good. Thank you, Renette, for joining us tonight.
Yeah. Bye, everyone.
Bye,
Yeah,
Renette.
Bye. Hey, I have a question.
Go
Yes.
ahead.
Who's the lady Geoengineering Free Canada? Who are you?
Yeah, my name is Bettina. Yeah, you weren't on when I introduced myself. So my name is
Okay.
Bettina. And I founded Geoengineering Free Canada about a little bit over 2 years ago. And so we did a lot of, obviously, research, and we joined Jim's ClimateViewer gang here a while ago. And so we found him, yeah, just right from the beginning, actually. And yeah, so I'm very humbled and honored that we are part of his gang and his group. And yeah, so that's what we are doing here in Canada.
And you're in BC?
I'm in BC. I'm located in Kelowna.
Ah, I remember back in the early days, there was some very big chemtrail activists from Kelowna.
Mm.
I don't know the names. They were anonymous.
Okay. Chemtrail. All right. Okay. Okay. What else? What other questions do we have? Anybody else? If not, then I have a question for you.
Okay.
What is radio sound?
A radio sound. Okay. That is a device, a little box. I've got this cool site that Stella found one day, Sound Hub Tracker. So this shows all of the radiosondes that they're measurement devices for temperature, pressure, and humidity. So they're launched every 12 hours across most of the world. Those are the ones that are still in the air. If you see a parachute, that means it's coming down. And they launch at 12Z and 0Z. Actually, they're mid-atmosphere by that time. They usually launch at like 45 minutes before, half hour before, but at about the same time. So most of them are still in the air. Here's the United States. And what it gives you is, I'll just pick a place down. Let's go to the bad part where the bad weather is. Where is that right now? Anybody got an exact location of where that bad cold front is by chance? I can
We
look.
had a little bit of shitty weather today. I woke up to snow this morning, And now it cleared up, so the sun came out again, but it was pretty cold and snowy this morning.
Okay, well, I think Kentucky's gonna be worse than yours, so I'm gonna go to Kentucky.
Okay, sounds good.
So here's Tennessee, there's Nashville, Kentucky's right north of that. So let's go and click on this one that's floating back down to earth right now.
Sun came out again, but it was pretty cold and snowy this morning.
Okay, well, I think Kentucky's gonna be worse than yours, so I'm gonna go to Kentucky.
Okay, sounds
What?
good.
What is that? There's a delay. There's Nashville, Kentucky's right north of that. So let's go and click on this one that's floating back. Can you guys, did you just hear that echo?
Yes.
Was that me?
Uh-uh.
I don't know what
I
that,
would
how
say
that
that
worked
was
out.
probably Jim's software that he's got on a bit of a delay because he's on doing a live stream.
Yeah, I just hit the live stream and I routed my system through my mic so that everybody could hear the live stream. So is it still echoing?
No.
No.
Okay, good. That means that I'm a good boy. But we're now
Oh.
live on YouTube, Rumble, X, BitChute, Odyssey, and Facebook. So to everybody who's watching, there's a Zoom link. And if you want to be part of the conversation, feel free to click that Zoom link and join, because this is not just a passive exercise. This is a learning experiment. We'd love to have you join. There's a link to the Substack. If you can't figure it out, go to climateviewer.substack.com and or geoengineeringfreecanada.substack.com. Both have a link to the Zoom call we're currently having, and we'd love to have you come and join and ask questions. Take it away, Jeff.
Okay. So this radiosonde, I've clicked on the first one. It did not have a good look to it. So I clicked on a second one. This is over somewhere near Kentucky, Columbia, Franklin. No, this is Nashville. So Tennessee. This shows the data that the radiosonde transmits back in the hour and a half or so that it's rising. It rises with this helium balloon, which is about 6 foot in diameter. And it rises about 5 meters per second until it gets to somewhere above 100,000 feet, unless it has a defect. Most of them get up to about 7 millibars when they pop. And that takes about hour and a half or so. So while it's going up, it's transmitting temperature and pressure and humidity. So I just clicked on a level. Let's see, 200 millibars is about the top of where most aircraft fly. 350 or 250 is dead center of the stratum that your high flying jet long cruises go. So this is showing me that at that location, as it was rising over Tennessee, it was minus 49 degrees Celsius with a dew point of minus 54. So that's a 5-degree difference in temperature. When you see 5 degrees in cirrus clouds, which are your high white feathery clouds, that tells you you got clouds forming and dissipating, and or one or the two, forming or dissipating when it has a 5-degree or less temperature spread. So it's also showing the wind speed is out of the west at 73.6 knots. These wind barbs show the same thing. But it gives you a numerical value wherever you click on that line. So like right there, 86 knots. If you go higher up, way above where aircraft fly, it's 20 knots up in the stratosphere. That little demarcation right there where it goes from cooling, I should go talk about these lines a little bit. I don't know. Should I get into the weeds like that?
Yes.
Okay.
Those are wind barbs, right?
Yeah, these are wind barbs over here. Yep. But there are lines in this thing, and it looks really confusing. This is called a dry adiabat. I don't want to get that much into the weeds, but that's the temperature that if you don't have a cloud, that's the cooling rate of the atmosphere, which comes out to about 10 degrees Celsius per kilometer. I'm not going to convert that to Fahrenheit per feet, it's doable, but it's not that 10 degrees Celsius per kilometer is the cooling rate if you don't have a cloud. So that's called the dry adiabat. There's a moist adiabat, which means after you get a cloud, it cools at that rate. I'm going to get rid of the dry adiabat. These are the moist adiabats. So because when you go from vapor to condensing, when it cools off enough, the temperature and the dew point become equal, a cloud forms, and it releases heat to the atmosphere. So at that point, when you continue to lift that air, it cools at a lesser rate because that heat that got released from, it's the opposite of evaporation. If you have a puddle of water, you got to put heat into the water to make it evaporate. It's the opposite when you go from the phase change from vapor to liquid. So the cooling rate is less. So you have these two lines that indicate the cooling rate. So right here is the moisture content. That's your dew points. These are the temperature lines. And you can see right here, here's 0. Here's -10, -20, -30. They slope lower left to upper right, -50. And when you get up to this point right here, it was a -73 dew point. That's the -60, -70 line. So you can see that they line up with the temperatures right here. And then one more set of lines is the pressures. This is called the skew-T log P diagram. And it's confusing looking until you break down the types of what each of these lines are. So these are the pressure levels on the left. 50 millibars.
Speaking of the millibars, like, how do I convert this to redneck? Because I don't be doing meters, man.
To redneck.
Yeah, this one doesn't have our redneck. Oh, there it is, feet.
Yeah,
Okay.
you guys really need to catch up.
I know. It's like, I actually like it better. I wish we would get caught up to
As
that.
we say in America, WTF is a kilometer.
You know, you
Okay.
guys, America is in line with Myanmar. They're the other ones that are still on imperial. And a little bit of Britain. Sorry.
Really, you're looking around 250 millibars. That's like a standard. You can find that on lots of other forecasts and so on.
Right. And that's dead center of the flight stratum for jets. So you're talking between 200 millibars. If I click on that, that's close to 40,000 feet. And 300 millibars is about 30,000. So if you multiply 9453 times 3.3, that gets you 30,000. 3.3 meters is 1 meter is 3.3 feet. So the point here is every single line you click on, you can watch this live. So when at 11:15 Z, these guys are going up, you can watch this trace growing as it's happening. So this is the data that a radiosonde gets. And why is this important? All this data twice a day, all around the world, is what they use. That is the major input for all of the weather models. And each of the weather models does a different set of calculations based on the people that built that weather model. And they think they're right, and they try to get righter all the time, but it's complex programs, big computers, and as we all know, nobody's got it right all the time. So
what you're saying, Jeff, from what I'm hearing here, is that what we're looking at right now on this radio sign is a Appleman-Schmidt criterion check mark that the chemtrails are in Tennessee despite them being banned.
this is not Appleman-Schmidt. This is skew-T log P.
You know what I mean. That,
yeah, well,
the data you're looking at, does it
yes.
Does it compute? Thank you.
Yes.
I'm answering the questions in the chat. There's a whole bunch of people are asking questions who have not joined the Zoom call. But they're asking about, what exactly does this mean? And what this means from what Jeff is trying to show you is this is how you actually look at the data in a vertical column of air, mostly vertical, because yes, balloons float around. And if the temperature, and blue is dew point depression, correct?
Correct.
If the temperature and the dew point depression at flight altitude are close enough, guess what that means? That means clouds. So, despite what everybody wants to believe about the Illuminati flying secret government planes and that's how we're getting all of this crap, you can go check this information yourself. We're in the deep end of the pool right now. Even Jeff has been sleeping on this webpage and not told me about it, but I'm pretty sure we're going to go look at the contrail finder on Windy in a little bit,
Yep.
so that everybody at home can try this themselves and verify for yourself. Are you looking at, the proper atmospheric conditions for planes to form clouds or not? But this is where all the science is derived from, are literally weathermen throwing weather balloons in the air with something called a radio sound on it, and we're looking at the original data that's used to make these determinations.
Zachary.
Can I just quickly interrupt, Jim? Why don't you just share our Zoom link in the chats and in your chats?
I'm spamming them.
Oh,
I put it in the details of all the videos, so they should be
Okay.
able to figure that out. But you know what? I may be giving you people in chat too much credit, so I'm gonna Dane comment just came in. Dane Wigington says we're already dead. Good night, everyone. From Dead Wolf Resistance 13. I love it. Keep it coming.
Hey,
Mike
Jim,
Decker chose
I have a
Black Buck.
question.
Go ahead. What's up, Jay?
Drink your iodine.
So back when you were on that the previous SKU-T,
Yes.
two lines suddenly make a right.
Yes.
Is that the tropopause?
Yes, it is. And
Okay.
in this case, I jumped over to Madagascar because I was getting bored with that one and the lines were too close together. This one shows different. You could see this is the tropopause is right there. That's
Good.
correct. 14,000 meters off of Madagascar. So 42,000 feet. And you could see in this one that these lines are really far apart, farther down at 8,000 meters. That's 25,000 feet. You could see it's a 30-degree temperature dew point spread. That's a dew point depression is what it's called. 31-degree difference. You have no clouds there. Down lower, you have -8 and -1. Clouds are going to be trying to form if you keep adding some moisture or if that temperature cools off to where those two numbers come down below 5. They're possibly forming there, but up here at the tropopause, you got cirrus clouds, 5-degree spread. When you have 5-degree spread, you've got clouds forming, and cirrus clouds are in the -30 cold and colder. You start getting contrails at -40 and colder. Persistent ones have to be 40 below or colder with additional moisture, and that contrail finder will show that. So, there's a whole bunch of radiosondes still floating down. Those are indicated by the parachutes. Nothing's going up right now because they all released at 0Z, which is about 3.5 hours ago. Everything's floating back to Earth right now. I'll take that back. Up in Alaska, they got one going up. There's a few going up yet. So they're off schedule. They don't, you can release them more often, but at least the National Weather Service does a twice-a-day schedule unless you have a hurricane coming or something like that, where it's critical data. So I don't want to get too deep into this, but if you go to plots, you can see horizontal wind speeds and all kinds of cool stuff on this thing. I mean, it shows they go up at 5 meters per second, but if you have a 100-knot wind going to the side, they're moving 20 or 30 meters per second sideways as well. So it's on an angle that they're going. They do not go straight up ever.
There's a question in the chat. Are you done, Jeff? Sorry,
Yes.
I didn't mean to
Yes.
what happens to them when they fall back to Earth?
They float down on a parachute and people actually find them. There's a thing right here that's got a little on this Sonde Hub tracker. They show the chase cars. So people actually chase these things and bring them back because they're valuable. I see it happening. Let's see if I got that correct. Let's see, where are some chase cars? That's beyond the scope of this thing, but people retrieve them. And for some reason right now,
I think you need to hit the enable button.
chase mode. Oh yeah. Thank you, Jim.
Welcome. Oh, you got to put in their call sign to actually chase the car. Good.
Okay, for some reason, yeah, I don't have the call sign for that, but it seems like I've seen this before where you see the icons of the chase cars on this site, and I don't see any right now. It's beyond the scope of this. It's not that important, but they're valuable. They cost money. I've been trying to get both Vaisala and the other one. I can't remember the name of it right now, but trying to sell me a Radisson because I want to do some of this and go out in Nevada and do some tests.
So
Under
Jeff,
inflate.
I have
Yeah.
a question because this has been like eating at me. Like as far as like real-time data, why are we still throwing balloons in the air and not using like drones that just go up to altitude, come back down, and then do it again 100 times a day?
Yeah, it got me. I mean, the technology's got to be there, right?
Hey, there's cars. I see cars now. Yeah, I mean, it seems like we could do better than this. You know what I mean? Instead of just throwing a balloon twice a day, why wouldn't we have a drone riding up and down a vertical column giving us, hourly updates?
Well,
And
I
that's
agree.
better
how
for
about this,
computer models.
Jeff? I mean, Jim, winds 100 miles an hour. How's the drone going to do it?
You got a good point. 150 knots. What's that thing gonna do up there?
Right.
It's going to fly. It's going to drift probably. Just
But
like
at
a
least
balloon.
it could fly back and then recharge and then go do it again.
Maybe.
I mean, I know we got Reaper drones that can fly up and deliver missiles. So, I mean, there's got to be some kind of drone. Anyway, I digress. Don't let me interrupt anymore. It's just, in my mind, like this seems like such old technology for us to be relying on that has not changed.
I agree. It seems very
I got a
archaic.
question on the
Yes.
technology. So I'm looking back. It was like maybe 2005. I was in communication with a guy named Patrick Minnis. You heard of him?
Yeah.
Okay. He told me that the Vaisala radiosondes had a dry bias at that time. You know anything about it? Have they solved that?
I couldn't say, Jay.
What he was saying is they tended to read dry, and it had to do with some kind of frost that was building up on the detector or whatever. And that was back, now that's almost 20 years now. So I don't know if they ever solved it or not, but
Well,
he
when
said,
I was launching them, they were way larger than they are now. They were monster sized. I mean, they were like probably 10 by 10 cube, and they were way smaller than now. They're the size of your hand right now.
okay,
So
well, maybe,
I would
technology
think,
gets better.
yes, you got to expect that.
That what he was telling me was at that time, if you look at a SCUT, just realize it may be reading a lower humidity than the actual. And I think it was not a whole lot, maybe 5%, something like that. Just a guess from what I remember.
You can go on the Vaisala's website. I know that I have, and they show the tolerances, and it's within a degree right now, I think, and the percentage has probably gotten better as well on the humidity. So
Good.
technology, you got to think it's gotten better, because when I look at the sky and I look up this right here, here's a place up in Columbus, Ohio, right up in the middle of that mess of heavy rain. The clouds are thick up top, 25,000 feet up to the tropopause and into the tropopause, because you've got convection. This time of day, there was heating. The sun's gone down now, but it actually broke through the tropopause. That moisture is up here, higher than the tropopause, which is right there. So you're in the stratosphere at 40,000 feet, and that moisture got into the stratosphere. Not a long ways, but a couple thousand feet, which is not normal. If you have a strong tropopause, that's resistant to vertical motion. The clouds are getting there because those thunderstorms are strong.
There's a question in the chat here from Martha. People are worried about the pollution like aluminum in the plane exhaust, plus the persistent cirrus. Is there any way to control what's coming out of the planes so there's less pollution and fewer persistent cirrus? Then the FAA could take credit for curing chemtrails?
Perfect question for Jim.
Yeah, I answered her and I said, currently the only solution that's really a viable solution is contrail avoidance. So you'll see this, hell, even Bill Gates is talking about this. He has a website called contrails.org, where Bill Gates and Ken Caldera are talking about contrail avoidance, because it's become like the new poster boy for climate change and avoiding carbon taxes. So they could claim carbon credits if they create cooling contrails and not warming contrails. But the only way to do that is to avoid the conditions that we're talking about here on the radio sign, to avoid ice supersaturated regions, or AKA contrail forming regions. In order to do that, they need real-time data. They need to be able to predict what's in front of the plane and what the climate impacts are going to be. The problem is that Ulrich Schumann at the ICAO colloquium on climate change in 2010 said, we want less warming, more cooling contrails, predictable for operational planning. When I interviewed Dr. Rangasai Halthori from the FAA, he said, we want more contrail-induced cirrus clouds during the day and none during the night. Kind of going back to the gentleman that Jay was just talking about, Patrick Menace, and his diurnal temperature range findings during 9/11. Isn't that correct, Jay?
Yeah. One thing I could comment about the person's question, their premise was that reducing aluminum might reduce the contrails, and I'm not so sure that's true.
Yeah, I would agree with you. It's more about carbon, black carbon. So soot emissions, for condensation to occur, it has to have something to condense on. And that's not always the case, but it's surely the case when you're talking about persistent contrail cirrus. So in order for cirrus clouds to form, you generally need something for them to form on. And that doesn't necessarily even have to be jet exhaust, because there's lots of other particles up there. There's mold, there's bacteria, there's minerals from, literally, like we were talking about this just the other day, Saharan dust. There's all types of minerals and particles and aerosols that ice can form on. But predominantly, if you read the literature from Schumann and other people, that are very predominant on this topic, they are, pretty much all in on black, black carbon soot is the condensation nuclei of choice when it comes to persistent contrail formation. So the only answer is it's not really the metals that are the problem, even though, was it Dan DeCizio? I can't ever pronounce his name. When he flew through contrail cirrus, whenever he flew through the cirrus clouds that were created, 75% of the cloud seeds in cirrus clouds were man-made metals. And that was a pretty famous paper. I think it was published 2013. So yeah, the metals are forming cirrus clouds. The ice are gathering on them, but it's commonly believed that there's some unknown factor where the organic particles, the carbon part releases and the metals remain. That's why Dan DeCizio, I can't pronounce his name. It's got two Z's in it. It's a weird name. Dan found that 75% of cloud condensation nuclei in cirrus clouds were man-made metals, but they found black carbon from jet fuel, from aviation-based jet fuel at 60,000 feet. The Indian Space Organization did that. Now, no plane is flying at 60,000 feet, so there's clearly some atmospheric science that nobody's been able to really figure out or understand. But what we can clearly understand is that jet exhaust ends up in the stratosphere and ends up at altitudes higher than planes are even flying, because the Indian Space Organization found black carbon from jet exhaust at 60,000 feet, and there were 10,000 per cubic centimeter. So there is some role that jet exhaust plays in contrail formation, but the best solution for dealing with planes making clouds blocking out the sun is to just avoid the areas doing that altogether. And there are companies like Satavia, which sounds a lot like marijuana, Satavia, that are already putting heads up displays in airplane cockpits and telling the pilots, here's the ice supersaturated regions in front of you. Either go 1,000 feet lower or, go up higher, and you could avoid creating contrails altogether. It's a very complex system to build, and most of the airlines are pushing back against it. And that's why the European Union's like now making a contrail observation network to gather more data to see the feasibility of a contrail avoidance scheme.
Well, look, I'm gonna use the RFK, and my girlfriend says I should use this more. I'm gonna push back a little bit.
I expected you would.
Because there were clouds before planes flew in the sky.
Yes.
So we can't say 100% that there would not be any contrails. If a modern jet took off in 1900, it might have still made contrails. We can't go back in history and find out, but there's no question that the soot has something to do with it. And I think it's going to be really fascinating to see what the hydrogen plane does. That's what I want to see. They're going to.
I talked to somebody who actually was involved in some of the early tests, and they're really pushing for what's called blue hydrogen. And I don't know if you've heard about the color code scheme for this, but anyway, the blue hydrogen based power plane actually produced they were saying magnitude of 10 fold contrails, because at the end you're just basically now producing way more water vapor.
Yeah.
I mean, it's clean. There's no metals. There's none of the other stuff that everybody's complaining about. But in reality, because it's hydrogen, it's the only, almost exclusively, there's some nitrogen, obviously, but that happens. But basically, it's all water vapor. And the test that they did, and I saw a video of it, I'll have to find that. The hydrogen power plane was just like and even Schumann speculated this before the test was even done. He says, I speculate that it will produce, massive contrails. So, and again, to your point, even if we did all of the above, if you go through if we had Tesla planes and there were no exhaust at all, just flying through certain contrail forming regions of high humidity, you're gonna still have aerodynamic contrails no matter what. You would agree, right, Jay?
Yeah, and actually, some of those are subvisual.
That's true.
You can't even
Can
see
I
it.
can I just address something about the clouds, the way they get reported now, as opposed to people saying, "Oh, they never used to look like that." And I'm not talking specifically about contrails or trails, whatever you want to call them, either. Even down to the things like the Lee wave clouds, which are like sort of the patterned type rows of clouds that people look at and go, they call HARP. I've been looking at Luke Howard's on the modification of cloud publication from 1803. And on page 33, it starts with a bunch of plates that I believe he himself actually created artistically and were referred to by a lot of people at the time, showing a whole bunch of those, thunderhead, the lee wave clouds, etc., which, 1803, that is, I believe it was before planes. So, and well before HARP. So people just need to bear in mind that there is a lot of misinformation and disbelief because they don't believe it in their own lifetime. But the fact that they don't believe it in their own lifetime doesn't mean it didn't happen. So just pointing that out.
I have a
Well, what I
question
see,
about
Stella, I've been in this 27 years now. And every year I hear somebody say, this didn't happen 5 years ago. And then
Yeah.
5 years later, they say, this didn't happen 5 years ago. I just saw these for the first time last year. So people's recollections vary.
Absolutely.
And on top of that, go back to the 80s when I started doing weather. I was in the Navy. We got 2 satellite pictures per hour, and they came out of a thermal printer. One was visible, one was infrared. Every half hour, they alternated. That was our look at weather. If we didn't see it on the news, what they reported is what we heard about. So that's the 80s. I'm talking the late 80s. That was the state of the art. We can't look at, like I'm looking right here at flight radar, and look at that. I mean, I can go anywhere around the world in a minute and find out where the ISSRs are, where the contrails are, where the lee clouds are. They're up in Washington right now, or Oregon, I saw earlier. You look out in the Pacific and Atlantic, there are huge areas of clouds where there's no aircraft. You don't need aircraft exhaust to have a condensation nuclei. You got the dust storms, you got the volcanic stuff, you got salt from all the the gales out in the oceans where the salt spray becomes a condensation nuclei and then the front kicks it up into the upper atmosphere. You don't need jet exhaust for clouds, and there's your evidence right there.
Well said. For those who don't understand that, before humans ever devised the wheel, there were clouds. There will always be clouds. The big problem is people seem to think that, like as Stella pointed out, that if you see a wave cloud, if there's any breaks that seem to be even in a cloud, that has to be HARP or some kind of radar. But, I too have seen the earliest descriptions of mackerel skies in like 1840s, the earliest photos of wave clouds being 1905. And this is long before we ever had, long distance, high powered radar. So there's a lot of confusion about clouds. And I think that, we're just trying to really deal with planes making clouds. That seems to be the theme of the day. So we're going to kind of just limit it to that. And when you can expect that, because I'm all right. I'm gonna be the chemtard tonight. I'm gonna be the chembicil. Jeff, why do I have spray days and not spray days?
Simple. The conditions are right at the edge of that cloud shield that's approaching. I mean, geez, look at Venture Sky right here. Go to clouds, high clouds, and it's going to show you where where the models are predicting that moisture to be tomorrow, the high clouds. Yeah. So you're going to see your persistent contrails on the edges of the high clouds. So if I want to look out 2 or 3 days, that's where it's going to be then. If you don't have the high clouds, you're not having contrails. And you're certainly not going to have a persistent contrail. So forget it up in Canada. It's not a spray day. It's as this moves in, you
Okay,
might
so
at
the
the edge of
Illuminati
this.
does not have a program running in Canada tomorrow. I just want to be clear on this because I know that you work for the Illuminati, and that's where you're
Right.
getting all these, CGI from your Illuminati buddies. But how come I get chemtrails every time it's about to rain?
I know.
I get chemtrails. Why, Jeff?
Why? Because the conditions are right at the edge of that cloud. You have cloud and you have not cloud right next to it. So you bring a jet right next to that high cloud. Now you just added moisture. You just decreased the temperature dew point spread by adding moisture. Now you have cloud right next to cloud where there was no cloud, and it's a linear cloud. Look at this chart right here.
You're
You could
telling
predict
me,
it.
so you're telling me, wise guy, that a 1500-degree jet engine actually cooled off the air. Are you trying to say that the water that came out of the plane is actually
Yes.
cooling, and that's what
Yes.
made? Okay.
That's the additional water from the burning of kerosene, which the product is CO2 and H2O, plus any metal that was in that fuel that didn't disappear into nothingness. So you add water and you have a linear cloud right next to that cirrus cloud. Watch some days where you have patchy cirrus clouds. You'll see that jet going across, and right where it's blue, you'll have no contrail or a very quick moving or quick dissipating contrail. As it gets next to that cloud, it's going to last a lot longer because the conditions are on the verge of cloud, on the edge of that cloud. Inject some moisture from the kerosene, now you got linear cloud.
And I have a question for you too. Why is the tropopause lower in Canada than in Mexico?
The atmosphere is thicker where you have more heat. So let me go to this thing right here. Here we go. Let's just look at some heights. This is called, this is University of Wyoming. So I can click on any of these sites right here. These are Radisson sites. So here's British Columbia. It's going to show me a chart that says the tropopause is 8286. And you can see it's the tropopause by that warming that's happening. This is the -50 line, and it actually gets warmer. This is -40 after it hits the tropopause because that's where your ozone is, and it's collecting the heat as the ultraviolet is going through it. It's heating that area up. Prior to that, it's cooling from 0 right here to -52, it looks like, and then it warms. So that's Canada. So if I go back now and pick a different one farther south, where you have warmer air, let's say Corpus Christi, tropopause 11693. That's about pretty close to 40,000 feet. Let's pick another one. How about Key West, ETW, 12,771. So that's above 40,000 feet. Multiply times 3.3. How about up by Hudson Bay? I don't know the name of that city. That one didn't work.
Grab Alaska.
Okay, here we go. How about extreme northern Alaska right there? 6911. 7
Bam.
times 3.3 is 22,000, 23,000 feet. Where it's colder, your tropopause is lower. Here's a little trick. Same thing is right there, but I want to look at the chart that's made from the radiosondes. That is a low pressure trough. That is where the cold air is. So if I were to pick Oklahoma at the base of that trough and look at that location, OUN is dead center of that. 8820, let me look at another one right next to that. Amarillo, Texas. 8505, so that's what, 26,000 feet? How about that's in Arkansas, 8382. But if you go to either side of those guys, away from that trough, Albuquerque, 10,000. That's the coldest air. Colder air is thinner. The atmosphere's thinner because cold is denser and it's more compact. Cold air.
I've got an example, a real world example.
Okay, these are live.
So say you have an empty plastic bottle,
right?
You put it in the microwave. What's going to happen to it? It's going to explode, right?
Yep.
Yeah. Yep. Because it heats up and
space.
Right.
First
The
law of
air inside there
thermodynamics,
takes
right?
up more space.
With an increase in temperature comes an increase in pressure.
If you put that bottle, believe it or not, if you put that bottle in the freezer, it could collapse due to shrinking. So near the tropics, near the equator, that the tropopause is, because the air is warmer, the tropopause is going to be higher because all the air is like puffed out. But as you get colder and colder towards the pole, it's going to get squeezed down. Does that make sense?
Yeah.
Yep.
Yep.
I like analogies.
Well,
I do too.
Take this place right here in Oklahoma though right now with a 8820. So that's say 25,000 feet. If I were to go to ADSB, where's my link for that? I'm gonna plug in 26,000 feet and go to that location. What that's telling you is every aircraft above 26,000 feet is in the stratosphere. What are they doing there, Mr. Jim?
They're injecting all their jet exhaust particles into the stratosphere. That is stratospheric aerosol injection. That's Bill Gates at work right now doing a geoengineering program, doing a one-over on it. As David Keith would say, even though Mexico banned geoengineering, they cannot ban planes from putting sulfur into the stratosphere because every single commercial flight is doing that every single day.
Well, they're up there because the air is easier to cruise through. It's
less turbulence.
It's thinner. So there's less power, less fuel, more speed.
And less turbulence because it's a stable area. You don't have, it's cold under warm is stable. Look at the stratus clouds off of San Francisco. You have cold water of 55 degrees. You get an inversion because of a high pressure ridge for large parts of the year. That causes warming descending air, and fly over that and look, it's gonna be flat because it's cold under warm. Do the opposite. Right here along that front right there where all that bad weather is over Tennessee and Kentucky, it's the opposite. You have the heating of the day, heating the surface. It's no longer, the sun's not up right now, but earlier they were worse because you put hot air under cold air aloft. That's unstable. You get thunderstorms with that situation. So what I was trying to show you here was Oklahoma City is that low spot on that trough. And I put in 26,000 feet and I'm zooming in. My internet's not working so great right now. It's not responding well, but my point here is it's giving you a count over here. As I zoom in, there's fewer and fewer aircraft on that screen. I'm just trying to get zoomed in on Oklahoma with 26,000 feet as my point right there. So I'm kind of zoomed in right there. There's 135 aircraft in that part of the world where they're very likely to be in the stratosphere. So persistent, it's going to stay in that stable place, the stratosphere, and circle the Earth at the speed of the winds. How long, Jim?
Well, lower stratosphere, we're talking 2 to anywhere from 5 days to about 2 weeks is the typical persistence time for aerosols in the lower stratosphere. But even then, because you're talking about such a low stratosphere, a low tropopause, that's going to fluctuate rapidly. So as the wind and the pressure moves east or west to east, it's going to get enveloped. So it's a that's this is one of the biggest misconceptions with stratospheric aerosol injection. When David Keith and Ken Caldera are talking about doing geoengineering stratospheric aerosol injection, the reason why they want to do it at 70 to 90,000 feet is so that it lasts for a very long time. The higher you loft the chemicals, the longer they're going to stay there. So if they put sulfur, aluminum, titanium, calcium, or diamond dust at 70 to 90,000 feet, they've only got to do it, you know, every 6 months to keep the levels pretty much stable. And that's the idea. And it's going to constantly be raining down. But in order to keep that shield of aerosols up there, they have a longer residence time. The lower you get, the shorter the residence time. So when planes are making, you know, contrails that turn into cirrus clouds, any exhaust that's in those, you know, coming out of those planes is generally going to rain out in like anywhere from 2 days to maybe a week at tops from 36,000 feet because the troposphere is very turbulent. It's not going to last a long time. It's going to rain out very quickly. The further you go up in the stratosphere, the longer the residence time with, you know, at 70 to 90,000 feet, we're talking 23 to 25, 20, possibly 27 kilometers. We're talking anywhere from like 6 months to 2 years for the same, if you put the same exact amount of sulfur at, you know, 40,000 feet. If you put it at 70,000 feet, we're talking anywhere from half a year to up to 2 years that it'll last at that location. And totally depends on what kind of chemical you loft also.
And they know that because they studied it from volcanoes.
That's right. The whole idea came from volcanoes. I mean, you can go back to Mikhail
Big volcano.
Boudico. Yeah, Mikhail Boudico with his Boudico blanket in 1962 proposed this idea. And then they really got their jollies when they watched the 1991 Mount Pinatubo eruption, because then they got to study it with more modern day science and they saw the global temperature fall. So they said, well, hell, we can do that. We can make man made volcanoes. But the only way to do that is at the upper part of the stratosphere, not at the lower part of the stratosphere where planes are flying. So for people to constantly be referring to contrail cirrus, planes making clouds as geoengineering, you don't really understand what geoengineering is, or at least what they intend to do. So it is a form of geoengineering in that it's a very short term geoengineering, but let's be realistic. Most of the science points towards contrail cirrus actually is a net warming even during the day. So despite all their claims that they want to make clouds by day to cool the planet and not trap heat at night, even during the day, according to Dr. Angus Hayal-Thori, they're still trapping heat during the day. It's not a very effective geoengineering program, if it is one at all.
Well, creating clouds does not necessarily mean that you are, you know, you're cooling the planet because it's trapped, right? I mean, it's a cloud blanket, so it's warmer under a cloud blanket, a cloud, you know, under clouds. When you have a clear skies as night, then it's pretty cold, right?
Yeah.
So, I mean, that's pretty obvious.
I think everybody kind of recognizes that, you know, that if you have a cloudy night, you're going to notice that the diurnal temperature range, the difference between the warmest part of the day and the coldest part of the night, is going to shrink. And you can look at this on your phone with your, you know, whether you got an iPhone or an Android, you can literally just pull up your weather app and look at what the temperature spread is going to be each day. And I'm seeing today our low was 65 and our high was 78. Now, that's only, you know, that's 23-degree difference. Later this week, I'm talking like a 40, 45-degree difference between hot and cold. And it's clear that day. Oh, surprise, there's no clouds expected that day. So, I mean, just with, you know, some good old redneck science, whip out your common weather app. You can, by just the basics that clouds have a heat trapping function. And that does keep warm air insulated at the ground
That's right.
because outgoing long wave radiation can escape.
Howdy, it's warmer. Warm.
What's up, Ferdinand?
Oh.
That you talking?
Whoops.
Go ahead. If you have a question, go ahead. But I have a question now. Just recently, there's been lots of discussion and talk about cloud seeding. And so cloud seeding obviously is happening in a completely different altitude. So does cloud seeding create clouds? I mean, the planes that are flying, are they creating
No,
clouds?
it doesn't create clouds.
Mm-hmm.
It
Why
seeds
not?
clouds.
They seed clouds, exactly. They seed clouds, but do they also? I mean, we were talking altitude here. We were talking troposphere. We were talking the commercial aviation. They are flying way up high. So obviously, everything that's way below that and cloud seeding is happening in a lower altitude is not creating clouds. It is seeding clouds. So those are contrails, chemtrails. What are they? What are they creating?
Well, it depends on how your definition, right?
Mm-hmm.
So they're seeding clouds to make it rain or snow. They're just basically nudging the cloud a little bit. You would never, no cloud seeder would ever go out in a clear sky and try to do it. It's worthless.
That's
There
exactly
has
right.
to be the moisture there in order to seed. It's like trying to seed a farm field with that's full of water. It just doesn't work.
Right.
In around, it was, I think it was 2010, a company called WeatherTech claimed to be using cloud ionizers, and they made a bold claim which really made everybody upset, that they were able to create clouds on demand in the United Arab Emirates. So the World Meteorological's expert team on weather modification went there to personally rebuke them with their cloud ionizers and say, this is highly suspect, and we do not believe any of their claims, and they have not been able to prove anything they're saying. So short of like, I think it's the J2X doghouse rocket. I've only seen a couple ways for man, to make clouds. In that case, we're talking about a hydrogen powered rocket that literally made a cloud, and a dude's on BBC going, NASA can control the weather, because he made a rain cloud. Like, he made a cloud from a rocket and then it rained on the guy. But generally speaking, cloud seeding is just adding more condensation nuclei. So it's CCN. It's either hygroscopic or it's glaciogenic. And we won't get too technical on this, but let's just put it this way. It's either silver iodide, or it's potassium chloride, or sodium chloride. So generally speaking, one's for warm cloud seeding, one's for cool cloud seeding. They also have what's called orographic cloud seeding, which is where they have ground-based cloud seeding generators and planes flying to do snowpack augmentation. That's where you're trying to put artificial snow on top of mountains so that in the springtime when they melt, not only do they provide water for people to drink, but in like Idaho, they do a lot of snowpack augmentation because they have a lot of hydroelectric power dams. So they need to fill those reservoirs for those dams to generate energy and drinking water. So there's many different people who are involved in funding cloud seeding projects. But again, cloud seeding projects tend to be from around 1,000 feet to 20,000. Jeff, would you say 20,000 feet max?
More like 16, 17, I've seen it.
Yeah. So
Yep.
anywhere in the teens. I put an infographic together recently. Dominic made it, and we just called it 1 to 10. And Jeff's like, I've seen him higher. I was like, screw you, Jeff. We just made the damn graphic.
Well, if it's glaciogenic, it would probably only happen at altitudes where there's freezing temperature.
Yeah, so that's where they go above it and they drop them into the top
Yeah.
of the cloud.
This
Yeah,
is the perfect situation that I have right here. This is yesterday morning, Oakland sounding, where you can see I've got the SQT in front of you right here.
Mhm.
This whole bottom area is really close. Dew point depressions are very small, near zero. That's thick clouds up to right there, up to
Prime cloud
9,000
kind
feet.
of
Look at that temperature, minus
yeah.
10. They seed at -5 to -10. So if you popped up right there, right above the cloud where it's dry, you can see it's dry by the wider spread right there. If you want to be not in icing conditions on the aircraft, you go in the dry layer right above the cloud and you shoot downward. I've shared that that video with 522 JP. What's that aircraft type called? Oh, come on.
Oh, you got me just now. Hold
King
on.
Air. The King Air.
Yeah.
They have belly flares that they can be above it and they shoot directly down into it. Usually they have them on the back of the wings, but they also have belly flares. So if you're getting icing on the aircraft, you pop above the clouds and you shoot down. And once you have this, the flares are from here. That's ideal situation yesterday morning, where you're at -9, pop up a little bit into the drier air and shoot down, and you have that entire area where there's nothing is going to evaporate. Whereas if you had, let's say at this level right here, 6 or 7,000 feet, if those two lines spread out to where it was a 10-degree difference, that means you'd be going through dry air and some of your rain would evaporate as it's dropping through that dry slot. In this case, it's perfect. You cannot ask for a better situation than that for cloud seeding with silver iodide. That was yesterday morning. And that aircraft that I've been tracking on flight radar, which is 904, I got a thing that pops up right here, 904 DK. They don't report anymore. They haven't reported. So they've been sitting there. They've been sitting there since the 6th of February with no flights. This was their last
Is
flight.
that the one that Mellow Cat had a conversation with, and now
This is the one. Yes.
You mean to tell me that? So Mellow Cat, the person who confronted the chemtrail pilots, confronted this Weather Modification Incorporated Beechcraft aircraft, King Air aircraft, and now they've privatized their flight logs. So it isn't, we can't see it anymore. So
I think what they did is,
huh?
I think what they've done is taken the ADS-B out of the plane and left it on the desk at the airport.
Yeah, so in doing that, there's been increased surveillance, which is apparently what she and many others are actually against. So well done. Good one.
Yeah, less transparency. Her actions actually led to less transparency. Good job, Mellow Cat. We're all very proud of you for making weather modification less transparent and being, making violent threats against pilots.
She's proud of herself enough for all of us.
Well, wasn't she said we need to get physical, right?
Yeah, we need to get physical. Well, you need to. I am tired of these. I have the transcript if you'd like.
I saw her try to explain it away, but
yeah, it was pretty pathetic.
Chemtrail extremist.
Let me move this over here.
Well, you can see on this thing, there's a altitude and speed graph where they were doing the circles. They were at a steady 13,200 feet that day. And the way you can figure out where they're going to be and when, you just use this app VentuSky that I showed you earlier. Anybody want to see that? How you figure it out?
Yep.
So you go to the temperature chart. First of all, you go to the precipitation chart, and it only happens west of the Rockies. So I've been following this location for 2 years plus right now. Sonora, California is the area where that 904 operates. Sonora, I'll plug that in right here so everybody can see it. Sonora right there is going to give us a little dot. Okay, so that's the location. So you go like this, zoom in on that spot, and then look for the time that the next precipitation is coming. So here's the 15th is today. And I won't be able to confirm it because they don't report anymore. I can't track them anymore. So I'm going to click forward a day at a time. I know we've got some more precip coming, but here we go. When that precip is just about there, they're going to be showing up just before it gets there. And it's like clockwork. This is 5 o'clock on the 16th, which is tomorrow. So they'll be there right before that. And the way I know the height for me to look on my flight radar is I want that -5 to -10 degrees. So I'm going to go to temperature. And I'm going to say, I'm going to guess about 10,000 feet. That's a good starting point. And the temperature at that level is -5. So, -13 rather. So that's a little too high. They're going to be more like at 9,000 feet. So I'm going to say 8,000. That's going to be somewhere between, there's your -5 at 8,000. So somewhere between, let's say 9,000 is where I'm going to expect them. That actually showed -1 at that time. When the precept's starting, -1, so 10 is going to be better. 10,000 feet. So then I go to my flight radar and zoom. I've got filters set up right here to where I go like this, and I put a custom filter in there, and I have one set for, I'll get rid of the 30 to 35,000. That's what's showing on the chart right now. 8 to 20,000 feet is the filter that I'd put in there. And then
That's your cloud seeding filter.
Wait, I got one more in there too. I got too much. I got 35 to 40,000. So now oh, it didn't go away. There we go. So these are the aircraft that are between 8 and 20,000 right now. So I would be looking at that location over Sonora at 8 to 20,000 feet at 5 o'clock tomorrow and looking for an aircraft showing up in that location. That's a really wide range that I gave, 8 to 20, but we're actually looking at something for about 10,000 feet. And once Sonora's right in here, here's Lake Tahoe. Sonora's down in this area right here. Here's Stockton. That guy launches out of Modesto. It doesn't even show him on the ground anymore. You can actually check to see if an aircraft is there by going into that.
What are these
airport.
grids that we're seeing? These white dotted grids.
Oh yeah, those are the jet highways.
You mean there are highways in the sky, Jeff?
Are they called skyways?
Are you trying to tell me there are skyways?
And they cross.
And they make X's and they make grid patterns. Is that what I'm seeing here?
Incredible.
Wait a freaking minute now. I've heard this from all of the chemtrail people that this is impossible, that all of the X's and grids could only mean that it's a secret government program, but there's clearly highways in the sky and the sky is a river. So if a plane comes down one highway and then it drifts off and then the next plane comes down the same highway, that's going to leave parallel lines. Am I missing something here? Or am I crazy? Because I'm seeing the flight lines right there in the app. It's not like it's a freaking secret or anything.
There's your live aircraft. They're on the lines in most cases.
Well, I'll be damned.
And I have highlighted 30 to 35,000 and 35 to 40. That's the aircraft that you're looking at right at cruising altitude. They're right on the lines in most cases.
Hey, show us the rich people that are flying above in their private jets above 40. I like to go to ADSB exchange for this one because they're always the pink planes.
Yeah.
That would be the elitist sphere. Yes.
Yeah, the elite, they're flying in the elitosphere. I love that. I'm going to use that, Stella.
I got, here we go. I'll put it 45,000 feet and higher.
Well, put it at
45.
43. Put it at 43,000 because
Okay.
I've seen them. They typically the private jet class, our betters tend to hang out at 43K and above in the elitosphere, as Stella said. And when you go and you look at it, it's almost exclusively private jets. I want to see if we can. Well, those don't look like pro. What are those down there by New Orleans?
Those are, here we go. Let's see. It's got to catch up here. My internet's having
Coming
some
back
trouble.
from the Caribbean vacation.
Yeah, yeah.
They go right over me. I'm in Southwest Florida, and there's a train of them going over me to Louisiana and heading back to San Francisco.
Yeah, there's a major highway that comes right there from where right below Tampa, all the way up to LA and San Francisco. And that is probably the busiest corridor, skyway in America.
I'm right underneath it in Florida.
Yeah, it's constantly a huge trail of. Oh, there's one big military plane that's flying pretty high up in Canada at the moment.
That's got to be a C-5, yeah.
Gonna be our new prime minister.
You mean the Carnival guy?
Carnival, yes.
I thought he was going to cut our power off. Where'd his balls go?
Yeah.
I mean, he literally said it and immediately lost his testicles like 15 minutes later.
Yeah.
That was pretty funny.
So there's 28 aircraft in the elitosphere up at 43,000 and higher over United States and down into Mexico and Canada.
So to be clear, the Davos crowd, when they're all going to fly to the middle of the rainforest where they actually leveled some rainforest so they could have their meeting in the rainforest, when they fly to their, global meeting on climate change, in the elitosphere, they don't make contrails, correct?
Correct.
Because it's too dry.
Correct.
And it's
also,
too warm.
Also, it's smoother, and they don't spill their champagne.
Their champagne is important. We don't want to get champagne on Al Gore's nuts, so they have to fly up there.
That's too funny.
Oh,
it's calm and dry, no turbulence. Yeah, they got it made up there.
So for those who are watching in the chat, understand that we've been doing this a while and watching this kind of activity for a while. So if we seem like we're all full of piss, did I use that right, Stella?
Close enough.
Okay.
Offensive enough, yes.
Okay. If we seem like we're all, just it's taking the piss. I used it wrong.
That's it.
Yeah. I'm not taking the piss out of you guys in chat. What I'm trying to say is that we're very sarcastic about this because with all of the fear around the chemtrail thing, it's really not healthy. And then you have to deal with all of the people who call us, government agents, shills. I've had some pretty colorful
Illuminati.
I mean, I do live in the finest double wide the Illuminati ever purchased. So, this double wide and this presentation brought to you by Illuminati. Let me make a little,
.tm.
What symbology do I need to use to be part of the Illuminati? I don't know.
Upside down triangle.
Okay, that'll work. So I can't.
IlluminatiRus.org.
Yes. So at the end of the day, we're sciencing over here. We're geeking out on how we, follow planes and tell when they're going to make clouds. But we have to laugh at this point because honestly, it's not popular. I don't know how to make. Is there a way we can make the Jeff? Can you like get a voice mod or something that makes you sound scary, and then we can put a really clickbait title on this, and then maybe somebody. Yes, that's right. Nothing as it seems. Just nailed it. I am now Agent Lee from now on. In fact, I got the haircut today just to prove that I am an agent. I mean, look at this military cut. If that's not a military cut, I don't know what is. Um, so I'm rocking my agent haircut today specifically for this broadcast. Um, it's just it's so
looks like you
fucking
had your
laughable at this point, huh?
you had your back to the big boy. So,
Yeah, I
never
mean,
mind. It's a nuclear joke. Never mind.
I don't understand you people down there. You know, like I'm gonna eventually get it.
All right then.
I love your accent though, so please continue.
So is there any weather related questions still? Troy, I know you got a question. I know you always have a question. Come on, go right ahead.
Hey, I
What
want
is life?
to see the windy.
Just so you know, Troy is in Nova Scotia. So Nova Scotia is 4 hours ahead of me. So it's really late at night. So, but I'm pretty sure he's got some questions here. Come on, Troy. Where are you?
Well, I don't know. I already asked my question earlier about chemtrails and weather systems and how they always seem to go together. When I see the chemtrails and then the rain comes in the next day, and that was explained quite well by Jeff. And yeah, I don't know. I saved I got some new websites to check out tonight, so that's a good bonus, and it's been very interesting. Yeah, I guess I don't have anything else to add.
I know a
Okay.
question. We haven't
Well,
covered the
that's
most
good.
important thing.
Okay.
The most important thing is the contrail finder,
Oh,
The plugin.
the plug-in. Okay, so this
I
is
helped made
windy.
this plugin, just so you know. I helped made this plugin.
That's very cool. So to get it, install Windy plugin, upper right corner after you click on the X. And then you have all these plugins, and mine shows that it's installed, so it shows at the top, but it was lower earlier on. But
It's way down there when you first start out. But
there's a lot of plugins. So I mean, I haven't investigated any of those. Thanks for Jim for pointing this out. And so anyway, when you click on the
before you go into
X,
this, full disclosure, one of my friends on X introduced me to the lady who wrote this plugin. And, basically I went through the GitHub repo on it. I was looking at the code associated with it, and I found some oddities with it. And we had a semi-lengthy discussion about it. And I was just pointing out to her that the radio sign was showing an inversion at, let's say, I'm just going to make a number up, 42,000 feet. And her contrail plugin was showing that there would be persistent contrails at 45,000 feet. And I was explaining to her how that's practically impossible. So and then I did a whole lot of questions on how does it work? How did you plug, where are you getting the data from? Directly from radio signs? Are you pulling them as CSVs? And she said, well, I'm pulling them from which model that you're currently on. So what are you on, GFS right now, or which model are you using? Do you know?
let me see. Hold on. I'll click on the contrail finder and click over to high clouds, and it'll show the models. So it defaults to ECMWF.
Okay. So depending on the model that you're using, that you have selected, will change what the contrail finder is going to show. Keep that in mind.
And that's
So-
the same with the hurricane tracker too. Well, same with
Yes.
all of them actually, because they all vary
So
about everything.
these are called ensemble models. So they draw different information, from, different sources. Generally, they all pretty much have the same sources. Some of them have different weights on different data. but they're just climate models and they're weather models.
Can you select the Illuminati model?
It says there's 5 more. We haven't seen what's in there. Jeff, what's in there?
Okay. So just for
A nom right there. Illuminami. I see it. It's there. Confirmed Illuminati model right there. 5 kilometers.
Illuminati confirmed.
So look at the
Look,
difference right there. Look at the
Yeah.
difference. That NAM model, North American model, shows one little patch up in Southern Oregon, whereas the ECMWF shows that. It even shows the wave clouds that are happening out there right now. The
Oh, look,
GFS.
HARP's on. Let's check if HARP's on right now. I need to pull up a web SDR and tune into 2.8 to 10
Next
megahertz.
rad. Next rad.
Oh,
HARP.
it's my harps.
So
After we
anyway,
oh, sorry, Jeff, you go.
no, go ahead, Stella. I was just gonna jump over to a different thing right here. So showing that HARP is on. If
That's
you believe
cool.
that
I
stuff.
mean, that's all the evidence I need to see.
So those are
Yeah,
wave clouds.
Jeff, why are those thin high ice clouds moving, but my HARP clouds aren't moving? Can you explain that?
It's the
Because
Doppler.
those guys down at the surface, the low water clouds are indicated in blue. This is called the day cloud phase distinction. It's wonderful for people that don't know how to read satellite data from. I mean, what they show you on the news is all white clouds. This makes distinctions for you. You could see, right here, you could see the snow in the mountains in the Sierras. It sticks out like a sore thumb. You could see orographic lift happening, and that's what these wave clouds are caused by. They're rising up over the terrain, over the Sierras. You've got strong winds perpendicular to the terrain, and because there's a high pressure ridge, and you can tell that by the form of these clouds, it's a bump. There's a high pressure ridge right here, which means there's an inversion. That inversion stops them from rising. Wind goes up the mountain, it hits the inversion, then it comes back down because of momentum. And when it goes down, the cloud dissipates, and then it warms up as it's descending. So it turns back up because it's colder air below.
I want to
and
use.
then it goes
I want
up.
to use a
It's
weather
the
term.
inversion again. It does it again and again and again.
I want to use a weather term. The fun effect.
Correct. FEHN, FOEHN.
I like calling it fun. It's more fun that way. I learned this term when having to explain to people what the hell happened in Lahaina. That basically the winds as they came over the mountaintops and then down into Lahaina, that they rapidly heat up and speed up as they rip down the mountainside. Is that correct, Jeff?
Yes. Well, you had valleys in that case too. So you had an inversion capping it. So it was funneled through that valley, and it couldn't rise above because of the inversion that was there. So it just went through that funnel down into the city.
I think you're wrong, Jeff, because I went to Google and I was going to make the video and I said, Google pronounce fun effect. And it said fun.
Okay. Chinook. Up in Montana, they call it a Chinook.
In Calgary too. That's
Derecho is another one. And
Yeah.
I don't know where that is, but derecho, that's maybe, I'm not sure. Somebody here would know. But
Means
yeah,
left.
it's a warming wind that's coming down slope after it dumps its moisture, after it rains out. And then that inversion keeps it down, and it's going up and down because the winds are strong. And wherever it goes down, it's dissipating the cloud. When it goes back up, as it cools, it forms a cloud. That's your lee clouds right there, all over Northern California.
Andrew in the live chat
Can I-
says, no, there's a GitHub project called Pi Contrails, which which that contrail map link I mentioned uses. I propose they fork that to also have a pi ship track, since ship tracks are even more concerning. Andrew nailed it, and what he's referring to on contrails.org with Bill Gates Breakthrough Energy. I've been all through their pi contrails. It's a Python script, but anyway, in it actually says, and Andrew, you can quote me on this, you can go look for yourself because you're already there. It says copyright, or credit Ulrich Schumann's contrail cirrus prediction tool. So when Ulrich Schumann said in 2010, we want less warming, more cooling contrails predictable for operational planning, he created something called COCIP, COCIP, the contrail cirrus prediction tool. That is what they're basing that contrails, that Python script that's running on contrails.org to predict whether they are warming or cooling contrails. But you're exactly right, brother.
So, shall we get back to trying to get to this contrail finder?
Yeah. Click on something. Let's see some numbers. and
Okay,
then
so
validate
first of
it.
all, while we're in this mode, notice where the thin high clouds are. That's these red guys right here. On a ridge of high pressure, all the middle clouds melted out due to the heating that happens there. That's a warming air mass under a high pressure ridge. So any mid clouds are gone. You got low clouds down near the surface that are happening, and those are the lee clouds that you see down below. So let's change to a different view and back to the view that is the best for seeing sea trails. So they are out there, and if you, I'll zoom in a bit, that Nevada area right now is loaded with them. They've
All
hit
right.
the tropopause and they've spread out and covered that entire area. I might have to go back and look at archived imagery a little bit here before
Go click the contrail finder right now. Let's go. Let's see it.
Okay, let's go there. So let's look at Medford, Oregon, Oakland, and Reno. Those are the three places that I think we can actually check to see that they're going to show up real well. So I'll go back again. Here's how you get to it. Contrail finder, and I'm leaving it on the default ECMWF model, and let's click on Medford, Oregon first.
You clicked right on the radio sign.
I clicked on the radio sign. Sorry, I wanted to click on the
I do
spot
it all
next
the
to
time.
it. I got to get rid of the radio sign.
I zoom in some, to
The only place I didn't want to hit is where I hit. Okay, so try right there. So there's your contrail possibility. So they don't even consider below 28,000. It's usually like 25,000, and they don't go above 43 because you're up into the stratosphere where it's too warm. So they're saying here
she made that
minimal
adjustment after I pointed it out, because it was showing up to 65,000 feet, and I was like, that's kind of uncalled for, don't you think?
Yeah.
And she updated the plugin, and I was like, let's go. Now I'm actually going to show this to Jeff. I wanted to test it thoroughly before showing this to anybody.
Yeah, and I did a lot. I put hours and hours into it, checking it over several days, and this is showing you the verbiage of where your possible contrails, your persistent ones are, and that's between 35 and 31,000. And detailed analysis shows will they form. So
show them the check mark.
It's based on that Schmidt-Appelman chart, and you don't have that stupid little chart anymore that I used to show people. This makes it really, really easy. So this blue and the green zone are where you have the possibilities. And what you're looking at here, they have a little legend thing at the very beginning before I actually clicked on any location that tells you how to interpret this. So what you're looking for is you're looking at this middle number here, this minus 40, compared to the actual forecast. If the actual forecast is colder and that moisture is high enough, this is the moisture column, RHW, That's relative humidity with respect to water. When you get above 60, you have a good chance of it for clouds or for contrails. Once you get into the 60s, it gets really good. And these are all in the 90s in the blue zone. And 60 is 35,000, 57 possibility right there. If you go down lower now, this shows the check marks for the best areas. So when you look at the RHW, relative humidity with respect to water, they're in the 90s, but ice needs a lower number. So it's way, way oversaturated. It's super saturated with respect to ice. So you're talking 150s, 146,
That's what we would
121.
call the ice super saturated region.
Yes.
That's an
So
ISSR that you're looking at right there.
Exactly. And why? Because that temperature is colder than the temperature that they say it has to be. And you have a lot of moisture there. So it gives check marks for the places that you're really going to see it really well. So if I were to click on another spot, like down here in, say, way down here in New Mexico, all of a sudden all the check marks go away because you're no longer near the Cirrus Shield. You're in dry air. It's way too dry. And if you go up to the top, short contrails possible, minimal contrails may be seen at 40,000. So you have enough moisture that you might get a shorty because there is moisture up there, but it's not going to be persistent. It doesn't meet the conditions. And if I click down in Texas, it would be the same thing. It just doesn't have the conditions. You don't get no check marks. Oh, by the way, there's the user guide that tells you how to use this. And
Andrew's pointing out in chat that he says that too bad it doesn't work on mobile. I was able to get it to work on Google Chrome on mobile. Maybe I should do a little tutorial or something on that, on how I fooled it into working. But yeah, I mean, I put screenshots of it from this phone in our Telegram chat, and I was able to get it working on mobile. Now, if you have the app, it will not work for sure. But when I tried it on just Chrome, and I think it also worked on Brave. At least on Android. I don't know about iPhones. I don't live in the I world. But at least on Android, I was able to get it to work.
that's
How I
cool.
do
It
it,
would be great. I'd love to see your tutorial on that, Jim.
I might be able to do it right now. Just hold it up to the freaking camera. Because I did do it, and it's probably still in my list of things, but I have so many tabs open. Just continue, Jeff. It's probably gonna take me the next 20 minutes to find it in these tabs.
So the real conditions showed that there's major contrails through Nevada, especially. Let's look at Oakland for the heck of it and see what that shows. Right, that area right there. And it's got long persistent contrails, 41,000 down to 36. And go down to the check marks, and you got a huge range where you have ice supersaturation right here with temperatures that are way colder than the maximum temperature that can be. So like 50 is what it can be. That's the warmest it can be, but you're expected 59 with 133% humidity with respect to ice. So that's why it gets a check mark. And it doesn't get a check mark at 42 because the RHI is below 100%. It's not super saturated with respect to ice at 42,000. Temperature is still good. It's saying you have to have no warmer than 52, and it's 59, but the moisture is not there. That's why it doesn't get a check. And down below, here you have a 48 with an 87%. Again, moisture is limiting. The temperature is good. It's colder. And the difference here, if you click on a different model, it's going to change things a little bit. So you could see the clouds change when you do that. And the icon model will be a little bit different. And the HRRR will be a little bit different. They're all a little bit different. The nice thing about the HRRR, it's a short-term model, but it's really, really accurate for short term. Whereas the ECMWF, the GFS, the NAM, they're longer term. The ICON is longer term. The HRRR is really accurate short term, and it gives good granularity, I guess you would say. So
Can I just add something there?
yes.
Just during the last episode that we had in Australia called Cyclone Alfred, that came much, much lower south from Queensland than usual. It is monsoon time, but it was very extreme. And I really got to have a good comparison of the models during that, because there was the hurricane tracker, which is that in Windy or Venture Sky? I always get them mixed up.
It's here.
It's in Windy. Yeah, there it is. Just above the radiosonde symbol there down the bottom. Yeah, that really showed the difference in the models very, very clearly, because there was a couple of similar-ish ones, and there was, a couple of others that looked nothing like the others, and it ended up really not doing anything that they all said. And they can only, I mean, it's only ever a guide, of course. But then I happened to catch the lady from the BOM, which is the Bureau of Meteorology, talking on the radio to somebody, and talk back, just saying, look, the fact is, we can only project. We have no idea, because they actually had people sort of ringing in, angry at the Bureau of Meteorology because they didn't get the 100 mils they were promised and all this sort of thing. And it's like, really? But anyway, the point being that just those sort of events, it's always worth checking the difference in the models, because it really shows you how they, for want of a better term, have no idea. It's purely just projection.
The way the forecaster does it is he she looks between the different models to see which one matches up with actual right now. There's your actual. Your high clouds are shown as the red. They go into Utah. Offshore, you can see the curvature of the jet stream right there. That's your high pressure ridge.
Look at Jeff.
Yeah.
That's
What's
it.
that?
Working. Can you bring me up to full screen? I'll show it. That is Contrail Finder working on Chrome. And all I did was I sent myself a link. This is hacking 101. There's nothing that's not possible if you don't think of a way of doing it. So what I'm going to do is I'm actually going to drag the Contrail Finder down halfway like this. And then I can actually click, boom. And now I have Contrail Finder on Chrome in the, just without even installing the plugin. And all I did was go to windy.com/ what's the URL? /plugin/contrails. So I just literally from my computer, I just texted myself the link and opened it. And sure enough, I can drag this up and down just by grabbing right here at the top, and you can pull it up and down, and you can scroll through all the data that's on it, and you can select things. It still works just fine. So it is possible to get it to work on Android. I knew I wasn't crazy. I was like, I figured out how to do it before. Let me see if I can try to figure it out again. I'll drop the link in chat. Here, try this on your mobile phones, guys. Let me, I got it on. All right, now this is going to everybody. To the people on Rumbles and YouTube, same time. All right. Just wanted to make sure that actually worked.
There's only one thing I don't like about this, and it's stupid. It's not really an issue. It doesn't look out to the next day. Jim, have you had any success?
No, it's
it
only
shows
current
now.
time. Yeah, it shows now. And even if you go try to progress into the future with the timeline down there, or if you change the time, it's not going to change with it.
Yep.
So, I mean,
even though
you can't. Hey, at least she was nice enough to write the dang thing.
It's superb.
I mean, I
It's
think it's phenomenal.
It's a game changer.
Does the contrail finder work in Mexico? It works worldwide. Show them. Go click something random.
Let's go click down here. Let's see if it changes. Yep, short contrails possible down in Mexico where I just clicked. Out in the middle of the Gulf, right there, it changes everywhere. I mean, out here in the Pacific, looks like it works everywhere. Go up to Edmonton area. Short contrails possible. Right in that high pressure center over near Hudson Bay. You got possibility up there, long, possibly persistent. But I have this, well, I don't think it's looking at that time that I've got that picture. That picture is forward in time. What we have is right now is actually what we got. So that's why it was saying it works up there near the Hudson Bay. Where's that high pressure center up in Canada? How about Alaska? In a dry area, no contrails predicted in the Aleutians. Nothing. Go out here near Kamchatka, way over here to the left, in that little patch right there. It works everywhere.
And for those who are asking in chat, you can actually just delete, and I'll just show you real quick. I'll delete everything but the plugin. You don't need anything. And this is pretty much true with every website you ever go to. If you share a link from Facebook and it has a question mark behind it and it says FBCLID, that is a Facebook click or client ID. That's a tracking link. You can just strip those off. So if I just put this in, and I'll share that with you guys. If I just put in windy.com/plugin/contrails, that's going to automatically load it, at least on mobile. Now, I've gone and done the exact same thing by just bringing up like private mode on, Chrome, and then click that same link. And at least on the desktop, it did not work. Okay, because I didn't previously install it. So results may vary. Maybe when the last time I was screwing this thing, I actually installed the plugin and that's why it's working in my Chrome now. Don't hold me to that.
And may I just add, for those of you out there, and I'm sure there's probably a few who don't like to put Google Chrome or Krugel Gome on anything, including devices, computers, whatever. It does work on Brave, and I'm using a Mac. So
yeah, it works on Firefox.
Try Brave.
Also, Brave, Firefox. I have a couple other browsers too. I have to have multiple browsers because I make, my website. So I try them on all of those.
Yeah,
but
I've got multiple browsers except for Chrome.
He leaves. Jeff, could you just, she's saying that it's not working on her PC. Could you just show them real quick again, go to Wendy and show them where the install plugin is?
Yeah. Right here at that.
Better than this.
That.
Do this.
Right
Do this real quick. Hit Control Shift N, or it's Control Shift P on Firefox. Sorry, you're a Macer.
Yes.
Command Shift P.
Catch up.
Command Shift P.
Yeah. Isn't that it for Firefox? Yes. Now go to windy.com.
Search for windy.com.
Just type windy.com. And enter. Okay. Now go to it, and you shouldn't have, because this should be in private, right?
I didn't notice if that was private mode or not.
Go to menu. Yeah, and now it's not installed. See, because now it's not cached. So we're just going to show tea leaves real quick for the people who didn't see it earlier. This is how you do it, and this is what it's going to look like when you go to find it.
There it is.
Install plugin. There's the contrail finder. Now click it and do the install.
Yep. It's not going to mess me up, Jim, is it? If I do this now,
this is you're in a private mode. See how it says private browsing in the top corner? That means it's not using any cached files on your PC. And that'll actually clear it out. So once you click on it, then you're going to click install plugin, and it'll say plugin was added to the main menu.
It's
So
quick.
Tea
It
Leaves,
took a second.
let me know in chat, just give me a thumbs up or something if that worked for you. So you can actually click open plugin right from there after you install it, but then it'll appear at the top of the screen in the menu, and you can see it listed right there. So that's the process for installing the plugin, or any of the other plugins for that matter, on windy.com.
And you want cloud mode. It won't work in all these modes, if you clicked on satellite, I mean, temperature, I don't think it works. You want high clouds in the ideal world. And I actually have to go and check. I have to remove something here. I got to arrange layers. I got to remove something to make room for that. I don't care about waves.
You can, if you zoom out, you're at 150%. That's why you don't have enough room.
Oh, okay. Well, I want to just
see where it says 150% in your bar, up
uh
in the menu bar, like where your URL is.
okay. Yeah, I see that now.
If
Okay.
you just hit Apple 0, it'll go back to default mode 100%.
And all these control alt delete things, they confuse me. Sorry.
He's like, keybinds, screw off.
Jeff,
Yes. Yes.
up in your URL address bar,
Yes.
okay, on the very far right, it says 150%. Just click on
Yeah.
that. Click on it.
Okay.
Click it.
Okay, now it should be back to 100%.
Okay. Well,
Okay.
I threw how, thank you for that. And you can drill that in again tomorrow, Stella.
Will do.
For me, you can just hold the control key and you can roll your mouse wheel to zoom in and out. So that'll like zoom it, like make it bigger or make it smaller, the interface. So you may have done that accidentally.
Well,
Mac people do have a control button, correct?
yeah. Macs do. Yeah. They're that advanced.
I was being
I'm the one that's not advanced, and I'm showing you my idiocy right now on my weaknesses. So
That's just the screen magnification, Jim.
just close this browser back out, because you only opened this up so we could show them how to install the plugin.
right. And I just showed how to get high clouds back in there as well. For anybody that hasn't used Windy, you can alter your things you can drag different parameters over there by deleting some of these and then dragging the new guys in. And then you say done, and then it'll have what you set for anybody that hasn't used Windy for that. So get rid of that and back to how I have it set. And you have to have it set on, it might work on humidity, probably not on temperature, but I like doing it on high clouds because that's what you're dealing with. You're looking at the cirrus layer. So that's where you should be to do your contrail finder.
I'm gonna try the in private mode and see if the plugin actually loads on my browser in private.
Guys, we are already into 2 hours, and it's been super fun for me, actually. And quite frankly, what I did before we started, or before I started this call here, I created a quiz. So I would like to. I have no idea how this works on Zoom.
Pop quiz?
Yeah, because we're making fun of it, right? So I have no idea how this works on Zoom. So it's been created on Zoom, and I will launch this right now. So let's see. Can you guys see this?
Yeah.
Uh-huh.
Okay.
Yes.
Oh my God.
Oh, come on.
4 questions. Okay.
Yeah, that's 4 questions.
I'm gonna nail this chat. Let's go.
Come on, let's
Who's
go.
going to be the test
You better
person?
get this. You better get this right, Jeff.
Everybody's watching my answer, so I'm kind of screwed if I'm
no.
Who's going to be the person that's want to guinea pig this? You're not asking me these. Who's going to be the guinea pig? Uh-oh. I don't hear anything.
You lost connection,
Oh,
Jeff.
nobody
I
volunteered.
did it.
Huh?
I'm
I'm not
told
giving
once.
my answers, man. I'm getting my 100 first.
Oh, man.
Chemtrails, I mean, that's freaking obvious. Duh.
Okay, who's answering?
I've done it.
Where do clouds form? In the stratosphere, in the
In the
tropopause, and in
sky.
troposphere.
I
And
like
in the
mine,
troposphere.
you know,
Somebody answered it.
since I'm a fence rider, I like mine on the tropopause.
Well, somehow this got answered. Did somebody click on these? Because are we all
I
sharing
did.
this?
I clicked on them.
Yeah, I clicked on mine. Isn't it all individual or what?
I'm
Yeah.
seeing filled out stuff. I didn't click on any and they're all filled out.
Oh, that must.
Where's
I thought
the
everybody
answer
was.
to it?
I thought everybody was getting their own
Yeah.
individual one.
I did
Oh,
my test.
right.
How'd I do, Bettina? Did I pass?
Go ahead, Frank. I can only see 100%, or I can only see the percentage. I can't see any names.
Oh, we don't get the name and shame.
No, I don't.
Oh.
I can't see any names.
What's up with these people, man? I mean, I need to shame somebody. So, like, can we get this together?
looks like the only one that had trouble was what are the clouds called created by jet emissions? That one, half of the people have got it right.
Mm-hmm. It's contrails or cirrus clouds, right?
The clouds created by jet emissions are cirrus clouds.
Mm-hmm.
Yeah, that's the clue.
Mm-hmm. That's
Yep.
the clue.
It's got cloud in the title.
Yeah.
In case you didn't notice from the last 10 years of me saying this, hashtag cirrus clouds matter.
Matter. Put it together.
I knew it was a trick question.
That's a cool little thing there, Bettina. Very
What
cool.
was that? Yeah. Thank you. I thought it was kind of fun. So I'll just end this.
Like-
Maybe I can see any names or something. No, I can't.
We pop a pop quiz on them.
I can. Okay, hang on. I can share results. Show correct answers to all.
Oh, phew.
Yay. Everybody saw I did it right. You guys saw me do it right. Nobody was flying that day. It was a no spray day. They told all of the secret government planes not to fly that day, and that's why nobody was flying that day. Those are just facts.
So what day are they going to be
I mean,
in
even the
British
Illuminati
Columbia?
need a day off. Sorry.
Okay.
What day are they going to send all the chemtrail pilots to British Columbia next?
That's a good question.
Right before the next low pressure.
Yep. Let's look at Venture Sky. Go to clouds. I want to get rid of that thing. That's a cool little thing. So go to Venture Sky because it doesn't work in windy. We know that. Go to high clouds. Go to today's date. When's the next chance of cirrus up there? There's probably not a day in the world that you don't get something up there this time of the year. Okay, my thing's not responding. Here we go. It is now. It's lagging.
Ah, poor Jeff. Doesn't have 1 gigabyte
Jeff,
per second fiber optic like I do.
if you turn
Correct.
the wind, Jeff, if you turn the wind animation off until you sort of get it all settled, that might help. It's in the bottom
Okay.
right-hand corner.
It's a lot of input,
Oh.
brother.
Wind animation. It's normal right now. Anyway, it's here.
I
Turn
think
it
there's
off.
there's an off setting, I believe, if you just check out that drop-down menu.
Yep.
Yep.
Good point. Thank you. I learned so many things from you, Stella.
Well, vice versa. So we're even.
So right now, you got the conditions up there. Ideal conditions for cirrus or for contrails, -40 or colder, 60% humidity or more. But once you get to 100% and it's really thick, you won't see the contrails. So 60% is a nice number. And the 16th, nope. Gonna have to go to send all those pilots over to eastern North Dakota tomorrow afternoon, and they can do their contrails, their chems, right at the leading edge of that band right there, up in Dakotas. So
Jeff?
better deploy those guys now so they can be there and get a good night of sleep.
Do you want to just quickly give an explanation as to what the blue and the red thingamyjigs are?
Yeah,
Please.
that's weather fronts. So you got the little lower right corner, you can turn them on or off. So the reds, those are that's warm air moving to the north. That's a warm front. This is a stationary front where you have alternating warm and cold teeth, the way I remember it. Cold teeth and warm, that's stationary. That front's not moving. This is a cold
Stagnating.
front.
Warm
These are
booby.
cold, which is cold air moving to the south when you have that blue teeth, cold teeth of winter. And over on the east coast, that storm that's over there right now, that's moving offshore tomorrow. That's 5 p.m. Pacific time. So 8 p.m. tomorrow night, that front that's wreaking havoc now over Kentucky, it's going to be offshore tomorrow afternoon, evening. So,
I have a
and the purple, by the way, is called an occluded front. That's where a warm front and a cold front catches the warm front and alters it. That's called an occluded front.
so
So
I
is that
I found another way to predict contrails. I use
tell us?
Earth Null School,
Mm-hmm.
set it up to look at 250 millibars, and
Mm-hmm.
it shows up as white. The ice supersaturated areas show up as white. Pretty good. It's pretty good.
So
Yeah, click on Earth. Yeah, and you've used it before.
yes.
Wind and 250 millibars.
Okay, where's wind?
Got it
Wind
on-
It's already
It's-
on wind.
250.
Yeah,
Okay.
the white areas are pretty good. You click on them, you could see wherever you click, you'll get a humidity, an RH.
Uh-huh.
So
Not seeing a number anywhere.
It's right
number will
there.
be
It
on
says
the
wind
little
215
pane on the
degrees
left.
at yeah.
It's showing the wind, but not the humidity.
Well, you have to click on RH.
See where it says
Oh.
overlay RH.
Okay. Overlay RH right there.
Yep.
Okay. Yeah. 100%.
Now it's showing it to you.
Yep. So that's Europe.
So somewhere around 70 and above is likely. That's the way
Okay.
I've been doing it.
Yeah. I've
Usually
observed
that's
that
fine.
60 and above, you can get persistent contrails, 60% humidity, but you need -40 degrees Celsius or
Right,
colder
right.
as well,
Right.
or a dew point depression of 4 or less.
Well, at 250, you're almost always going to be cold, but maybe not 40, but depends. Yeah. Yeah, I look at both.
I like that.
So
That map is cool.
there's a whole bunch of comments flooding in right now. And what I want people to understand is that what we're trying to show you here is everything's not visible. Like when you can't see invisible water vapor in the sky. And what we're showing you are the tools that the artificial redneck weathermen use to be able to predict this stuff. And Jeff's an actual weatherman explaining it, like data on the Starship Enterprise. he understands it way better than any of us, but even you can understand this stuff. You should be able to follow along, even if you got to go back and roll this video back. Definitely check out Stella Q. Isn't it Stella Q Australia, or is it just Stella Q now on YouTube?
It's Stella Q Australia.
It's Stella Q Australia on YouTube. Watch their episodes, whether or not. Jeff and Stella have done several episodes on this, breaking down how to use radiosonde data and all of these sources. So you can take your time to learn this for yourself, and then not only be staring at the flight tracker and figuring out, are the flights in the area where the water vapor is going to create contrail cirrus clouds that block out the sun. And then I hope that if you learn this information, you will then go to your favorite, you know, Kimbasel friend and go, bro, man, dude, you need to be able to look at this and go, the reason it's not a spray date, because there was literally a comment, literally just a second. Here it is. Crabba Whiskey says yesterday they were spraying heavy in the Gulf of America and Central Florida. Spraying, for me, I don't know about you, it's a trigger word. So like I'm gonna go to my safe space because I cannot handle the word anymore. Don't say spraying around me. Because if you haven't taken the time to do your homework on what contrail forming regions are, what ice supersaturated regions are, when you have literally the world's best instruments at your fingertips and literally have been shown how to use them, you have no excuse at this point to claim ignorance. So again, watch Stella Q Australia's YouTube channel. Go there and subscribe, and tell Stella when you leave a comment that Jim sent you.
The link is in the chat here on Zoom, Jim. If that's
Yeah,
any
and
help.
I'll
To the whole
you know what?
conference.
I'm gonna grab it real quick and I'm gonna throw it in. Damn it, I have too many windows. Where did the
You're on Windows.
I'm
with
on
Windows.
I'm on Winblows, and I'm looking
I'm on
for,
Mac, and I've got no Macs in front of me.
I got the Zoom chat just disappeared on me. That's probably because I closed it. There it is. Thanks. All right, I'll just drop that in chat for everybody. Bookmark it, learn it, love it, teach it to others, become the Illuminati member you were born to be. Go out and scare your friends and predict when the chemtrails are going to have, and troll, baby, troll. I want to see everybody trolling all of the people and going, I can predict when the chemtrails are going to happen. And then, because now you know all of the tricks to fool your friends. It's a cool party trick. All the cool kids are doing it. Yep.
And one more thing to just show you real quick. When you go to RAM slider, and I provided a whole bunch of links. I don't know if any of you guys dropped them in chat.
I did.
There's an archive. You can go back in time and see what the conditions were. You just click on the drop downs and change the times, and you can change the time steps. This is set for 30 minutes right now. And you could change the location. These are the different satellites that you can go to, the different products, and this dust UMET set is the best one for looking for the chems. Northern Florida had some, looks like yesterday. There's a million different products, but if you just concentrate on a couple, this one takes care of the chems. And that day cloud distinction one, it's not going to work right now because it's dark over here, but it would work in Australia. If I go to Australia, day cloud would work. day cloud distinction, which is right down here, because you guys are still light over there, and it makes great. This is the best one to start out with if you're not looking for the chems, because it gives you the cloud layers and tells you
And
which
it's
ones are
just
the high
gorgeous.
and low. It's superb.
Absolutely gorgeous.
It's amazing.
Compared to me getting one every half hour when I was in the Navy on thermal paper.
So the Gozar and the Japanese Himawari, they take an image every 10 minutes. How far back does the archive go? Do you know? I
Like a
would
month.
assume they go back to like, okay, never mind.
Like a month.
Because they just launched when I first came across this website, it was the Himawari 8. Now they're using the Himawari 9. And the same with the Goes 17 became the Goes 18. So obviously these satellites don't have a very long lifespan or something. Because just in the time that I've been going to this website, um, they've changed the satellites. But they're all part of what, at least the 17, the 16 and the 18, they're part of what's called GOES R. The old GOES satellites were pretty shitty. If you look at them in comparison, the new ones have just so many different data sets. But the thing is, it's an absolutely huge amount of data. So if you don't have fast internet or a fast computer, if your computer's kind of like, 10 years old, you may actually have this lock up on you. So be careful when you go zooming in and out. It's going to reload the entire thing because it's a full disk image taken every 10 minutes and then creating an animation out of that.
Pretty awesome.
I love it. I mean,
Go anywhere in the world.
it triggers flat earthers like so hard.
I
mean,
was just about to say, and the Earth is round. Yeah, it is, isn't it?
Dang.
like they really get triggered over this thing, and I think it's absolutely hilarious. And then they're like, well, but this is all NASA, and I'm like, well, what about the Japanese? I'm pretty sure they're not NASA. And so I bring up the Himawari, and they're like, well, it's still all CGI. And I'm like, yeah, but this is CGI.
Trilateral Commission.
This has got a CCD in it, and it's computer generated imagery. It's not like I've got, freaking, it's not a SLR camera. This is just as much CGI as the satellite is. Oh Lord, man. We go round and round on X,
Round and round on flat Earth.
yeah, we go round the ice wall and round we go.
I was thinking that actually yesterday when I was watching that really high altitude glider video. I don't know if you guys saw that. So was that 70,000 feet or something? 70,000 something that it got up to. And it was like, he said, yeah, right up here, I can start to see the curvature of the Earth. And I'm thinking, uh-oh. Don't say that, brother.
It's called a globe head. I'm going to pin that one for a minute. Oh, Lord. But the point I was trying to make is that you can literally go and Wendy actually has a layer on there for live webcams as well.
Yes.
Yeah.
Right there.
Good.
One of the good things about this is that you can bring up your contrail finder, you can look at the RAMD slider, and then you can actually go to a webcam and go, is it CGI? Well, guess what? I just looked at the live webcam that's showing that the data that I'm seeing is real. So and then if you don't trust any of that, go to different websites that have webcams all over the planet. And then there's an entire science observational network called All Sky Cameras, which literally point straight up, and they have a 360-degree view of the sky. And I can look at that. So to all the people who say everything that we're looking at is just government propaganda, CIA's, CGI, you can go and you can look at these webcams in real time and then verify for yourself. And if you don't trust that, phone a friend. I mean, like just call somebody up and be like, can I do FaceTime with you real quick? Because I just want to do a quick experiment. Could you look up at the sky? Because this contrail finder says that there should be chemtrails over your house. Ah, shit, it's right. So I've done all of the above. I've been on Zoom calls with people. I've been, talking to people who call me and I'm like, hey, real quick, we're talking. Can you take a photo of the sky and just text it to me? And they're like, oh, yeah, it's a mess out here right now. And I'm like, okay, just checking. Trust but verify. Okay. I don't even trust. I just verify. And I want to give credit where credit's due. The Chief 762 here in chat literally broke my balls for 10 years straight. We did this every single day. And here comes the young buck, so confident, but my chemtrails. And he's like, but they're contrails. But status 450, it's barium salt. And there is like, there's no barium salt in that. And I'm like, son of a bitch, I put that in like 6 articles and I had to go back and delete. I'm like, oh God. The number of times I thought I had it figured out. I'm not making fun of anybody who believes in chemtrails. What I'm trying to tell you is I was you. The difference is I'm not too proud to admit I was wrong. And it was through a plethora of evidence and being willing to talk to people who disagree with me. Because guess what? You want to be in an echo chamber, you want to live in a world full of cognitive dissonance and confirmation bias, go right ahead. Be afraid of clouds, be afraid of, the sky. You do you. But my suggestion is if you really care about this, I can't pin that comment. You can't say the F-bomb. That is funny as hell, but I can't pin that. Somebody just did a F-bomb version of the trust thing anyway. The point I'm trying to make is this. Like I too was a chembicil. I am a former chemtard. And it's through confrontation with people who disagreed with me, who tested my ability to understand, new concepts. We all have to be willing to grow. So always a student, sometimes a teacher, never an expert. I don't think I'll ever have it all figured out. I think I can teach some of this stuff pretty well, but I'm always willing to learn more. Jeff has taught me more in the last 2 years than anybody I've met in a very long time because I'm not a fucking meteorologist. I mean, like how many people are overwhelmed by some of the stuff Jeff's saying today? That's why it's valuable because don't feel overwhelmed by the fact that you cannot understand every word coming out of his mouth. It comes with time. And you don't have to understand it all, but you can understand at least the basics enough to be able to go, should I see clouds on these days? Why is there a spray day today and not tomorrow? This is pretty basic. And we're giving you all the tools. Jeff and Stella have done multiple podcasts on this. Check out whether or not, I'm going to put it in chat again, and I'm actually just going to I put a playlist up of all their stuff. But what I'm going to do this time is I'm just going to put her channel in there. And I'm going to put that out and I'm going to pin it on the damn screen. So
Also,
I want you guys
can I
to
just
go. Good.
Can I just make a little addition there? The problem too is that data is not sexy. It does take time and it takes
Yeah.
dedication and it takes concentration, which, not everybody has that. Sure. But if people have got time to sit there and watch 12 5-minute things or even less, they've got time to watch one 1 hour thing. So even if you break it up into increments, it's worth spending 1 hour to possibly affect maybe the way you are in life, as in extremes, like one lady wouldn't even go outside when there were contrails because she was scared of the sky. I mean, that's completely unacceptable. And the difference being education. It's that simple. So just bridge that gap, and it just takes a little bit of time, maybe a couple of hours here and there, but it's time you spend once and you won't forget that stuff. So data ain't sexy, but I do try to throw in a few little things to make it fun. But it's just not. It's data-tainment. It's not entertainment. So
I find it very sexy. I mean,
yeah, well, I know you do. But
I'm a nerd.
You're a
Okay,
freak.
like I am a coder. I'm a hacker. I've been a hacker since I was 12. So like, all of this stuff gives me the will. Like, I look at these maps, and right now I'm trying to use AI to rip RAM-B sliders data so that I can put it into my ClimateViewer 3D so I can have it for myself in my own map and then overlay all the other things I have. Because what I want to do in a perfect world is bring up the RAM-B sliders like GOES 17 and show the wave clouds, and then bring up all of the high powered radar, missile defense radars, the ionospheric heaters, the Mattis wind radars, like every radar on the planet, and then bring up all the high powered ELF and VLF transmitters, like all of these things, and go, all right, so all these things are here. These are on right now. Like all the things that I'm showing you are on right now simultaneously. But people are making videos about NextRads like it's hotcakes, and fools are out there happily lapping it up.
We're not
And
seeing your screen, by the way.
I can see Jeff's screen. I see a radio sign.
Oh, right. Sorry. I thought you were showing something. Carry on.
No, don't get me started, because you know how I am with screen sharing. I got way too much to share. I overshare.
Yeah, no, I thought you were referring to something you were trying to show us. That's all.
No,
I just got confused.
No, I was talking about the RAM-B slider. Like we're trying to figure out how to get that data into cesium, which is a WebGL 3D globe. But in order to be able to do that, it's a full disk image, which I would then have to wrap around a 3D globe, which means there would be distortions and all of that. And then there's the whole timeline issue of being able to create sliders, and I'd literally have to create an entirely new interface. So I don't think it's even possible at this point. I'm really sad about it. In fact, I'm just going to shut up and mope now.
Well,
You got data envy?
I do. I really do. That thing is sexy, and I want it for myself. I want it. Like, I can go and get anything from NASA Gibbs, so I can grab like everything from the Global Image Browsing Service. I have all the EU METSAT data. I can grab all that in either WMS format or like Esri's ArcGIS. But as far as the GOES 16, the GOES R series, and the Himawari, there's not a like open source repository for it. And the only format I've even been able to find it in is like called NetCDF. Now I'm nerding out about science data. Now you got me running my mouth about science and freaking GIS, and I'm just going to shut up. I am a dork.
Looks like some good lee waves there, Jeff, that we're looking at.
They
now.
are. And here's I wanted to point this out too. At 10,000 feet, 9,368 feet, you got the inversion that you have to have a lee cloud. That's what turns the winds down. And when it turns down, it warms. And that's why you get the gaps in the clouds. And the winds up there are 46 knots. So they're perpendicular to the Sierras. Sierras run right there. It causes the moist air to fly up the mountain, hits the inversion, turns down. Where it turns down, it dissipates the clouds. Then it turns back up. And where it comes back up, you get a line of clouds and turns back down. hits the inversion again, and just keeps on like a like a wave pattern, like a sine wave. You
What's
have to have the
interesting is
inversion.
you can almost see that it's like it's stationary waves. So these are called standing waves. And that's the thing that people don't understand about the whole like broken contrail thing either. That there's actually a standing wave. So it is standing in position. It is stationary almost. And that's why you're basically having heat and cold traveling up and down, which can create this dashed line. And of course, a lot of people are like, oh, well, that doesn't explain everything. Well, no, asshole. I can't put a bumper sticker that explains everything, but it's, I find that like 90% of arguments made, that all of these are, but my chemtrails, you're like, well, ice supersaturated regions, but my dotted line chemtrails, it's always like whataboutism, as what they call it in debate. It's always whataboutism with like 90% of these people because, once you believe something long enough, it's simply too painful to admit to yourself that you were wrong. So I think what Renette said earlier really captured it well. We gave her a call, well, she called us, and by us, I mean my wife and I, and we both were, like my wife normally is just like, I don't care about your chemtrail crap. And I'm like, yeah, but Renette really like, she really said it well and put people in their place today. And that takes guts, man,
That's
because,
great.
yeah, I mean, I was like, dude, you really went hard in the paint, and most people do not have the guts. Like when it took, when I first said the word contrail cirrus, like the whole damn world just fell in on me and wanted to attack me. And I was just like, you know what? I don't really give a damn if you guys don't like what I'm saying because at the end of the day, this is the truth. This is where I'm at in my journey. And I hope that other people will come along on this journey because the bottom line is whether you believe in chemtrails or contrails, what we agree on is I don't like planes ruining a sunny day. It's really that simple for me.
Yep.
So it
Just
should be
getting back,
that. Go ahead,
just
Stella.
getting back to the clouds here. I think probably the best way that it was described to me, which was said by you, Jim, and it was sort of stating the obvious. I just hadn't really thought of it like this, but the sky is a river. And so when we're looking at things like the standing waves there or lee waves, they have several different names. It's just like ripples. So I just always, when I see something strange in the sky, I try to imagine what it would look like in like a river with rocks sticking out and sort of imagine what the path of water would be. And that's basically what we're looking at. We just can't see the rocks, but they're things like patches of hot air and stuff like that. So once you start thinking of the sky as a river and water, everything starts to make more sense.
Yeah, and the people who model this stuff, it's called fluid dynamics for a reason. In fact, Mick West, who was, Jay's, right hand man at Metabunk, Mick West was a programmer at Bullfrog Entertainment and created Tony Hawk Pro Skater. And one of his specialties was fluid dynamics programming. Why? Because you need to understand physics and fluid dynamics for a skateboard to go up in the air and drift for a second and then fall back down and then catch it. I played the hell out of that game back in the day. But at the end of the day, all of this is fluid dynamics because the air above us is a fluid. And that's like an aha moment for, a lot of people. Once you realize that it's very similar, especially the people who point out like those islands, I keep forgetting the names of them, the ones that are down there. Anyway, doesn't matter. Southern Hemisphere, and they're constantly making these huge ripple waves, and everybody's like, "But my harps," and I'm like, "No, that's actually a mountain range. It's just
Sandwich Islands.
Sandwich Islands."
Yes.
And those are constantly, making these huge ripple waves, and you're like, think about a small stream and a rock sticking up from the stream, what happens? You have ripples coming off of it. It's like wake, the wake from a boat. You've got this
Exactly.
boat that's sticking into the river above you, and it's creating a wake. And when you think about it, like in an oversimplified, it's oversimplified, obviously. But it rings very true to like what you actually observe. So, I don't know. Take a different look at it, and then you'll notice that it is very similar in nature to skipping rocks or like jet skis. Like be an observational scientist. That's what we're asking people here. Don't just trust what you see on your screen. Use what you see on your screen to then go outside and make an observation yourself, and then find the truth somewhere in between. Go, well, yes, it says that it should be this at this altitude. I'm checking this flight tracker. I'm not seeing the flight I want. I'm going to go check globe.adsbexchange.com. Let me check another flight tracker. Make sure, because a lot of people will go, it's just military craft. Oh, well, the chemtrails I'm seeing, Jim Lee, they don't show up on flight trackers, Jim Lee. And that's what I hear that all the time. And I'm like, but that like never happens.
And
Like,
not only that, you can get to enjoy the sky again instead of being so bloody angry at it all the time. Because I
yeah,
was there too. I've
yeah. I
been there.
mean,
I was a chemtard, conspiratard, whatever. And not saying that they're not doing anything, other things that they shouldn't be doing. But as far as this goes, a lot of it can be eradicated. A lot of the crap can be eradicated by a bit of education. It's really that simple.
Hey, Jim,
Simple science, simple physics, and simple couple of hours looking at this
you
stuff.
mentioned
Project.
people that can't find the planes on flight radar, etc.
yeah,
I think the biggest impediment to that is that people have a very small view of the world.
yeah,
They don't realize that you can see a plane 50, even 75 miles away. And they think that if they see a plane in the sky, it's got to be within 5 miles of me.
yeah.
And
I
there's
saw Mick had done that Google Earth file
yes,
to try to show people what your actual focal distance is for seeing a plane, even going over the horizon, and people have no clue how far that is.
speaking of Google Earth files, do y'all see the background in my image there?
Yeah,
Can you see that?
yeah.
Mm-hmm.
I downloaded the full day's flight KLM files for Dane Wigington's house. And what you're looking at is the day's tracks of all the plane. You're on top of his house, and those are the day's tracks that could be seen from his house. He is underneath a tremendous flight path. Everything up and down the West Coast, going from Seattle
Yeah.
to LA, is going right over his house.
Yep, there's that. And then there's that woman that went and confronted the pilot. It's a bit berserko in the middle of the night, but same deal. They've been doing that project for 30 years. She didn't do her research before she moved to the area, quite clearly. So,
Now, when
what do you do?
Dane first started, he said there can't be more than 4 or 5 flights a day over my house.
Yeah.
And so
Dude, that's so obviously false.
I wasn't savvy on how to do this. I just sat there one afternoon and downloaded one flight, the next flight, the next flight. I sat there all afternoon on an average day and downloaded them all. That's what it came out to be.
I used to have a Google Earth file that was um basically it was called Flight Aware. And Flight Aware, yeah, and Flight Aware, I could actually show all of the flights over America. And then on Google Earth, I could actually stretch the timeline out and it would show all of the trails from beginning to end, from where they took off to where they landed. And by the end of the day, and then I would show everybody, I could very easily show everybody, here's all your X's and grid patterns, because now I can show you the entire day, all of their flight paths, and do it in Google Earth. And it was on ClimateViewer 3D, but then Google Earth said, we're doing away with the Google Earth plugin, and I had to reprogram the entire website from scratch. And then FlightAware was like all the other flight companies, hey, we can make money on selling API access. We're not just going to give this shit away for free anymore. And now it's like, it's harder to, get this kind of information unless you do what the hard work, like you said, and go and literally download every single flight and then map it out yourself. So, I mean, the internet has gotten a little more greedy, and that is making it tougher for people to be able to see these. But I mean, you can clearly see right there on the screen where he's showing the the Shasta high Skyway, and that's not something new. Um, I've shared it 100,000 times that, in 1958, Palm Springs was complaining to the U.S. Air Force that their skies were being blocked out by vapor trails that fanned out and blocked out the sun. And the U.S. Air Force basically came to the city of Palm Springs 1 month later in January 1959 and said, you live under the busiest intersection of all West Coast traffic. So you can either live with the trails or you can move the city of Palm Springs. And that's a reality. I mean, that is documented history from 1958. So to the people who say contrails aren't real, you're making this up. Google faked the newspapers. Like, the overwhelming amount of evidence says that this has been a problem for a very long time. And maybe you don't even consider it a problem. Some people just are like, hey, it's just condensation trails, get over it. But for me, when I look at, in 2004, there were 23 million flights globally, not including military. So that's commercial, cargo, and freight. In 2019, there were 43 million flights globally. At that rate, if we continue this, over densely populated areas where you've got skyways over your hometown, good luck, buddy. Unfortunately for you, like, I live near Shaw Air Force Base, which is flanked by Shaw bombing range. So, generally speaking, I was kind of oblivious in my hometown to the problem that a lot of other people are seeing. Like, I'm not seeing what you're seeing. But because I'm a security officer, proof right here. There's my gun. There's my badge. I took a job in the neighboring county, literally one county away. And because I live near Shaw Air Force Base and Shaw Bombing Range, all of the flight traffic was being routed to the counties on the east and west of my county because they can't fly over that airspace. So when I would go to work in Manning, which is next to Sumter, I would see all day long because that's where all the flights were being routed around. So it is a highly localized issue, and you might not even notice it. You might be one of the lucky few. And I mean, honestly, the global estimates are only like 15% of the globe are covered in contrail cirrus or cirrus clouds, period. So to the Western world, let's just say the Northern Hemisphere, to all the cell phone holding people, this is the biggest problem facing humanity. It's the end of the freaking world. But a lot of the Southern Hemisphere, they're not seeing the same thing that we have. I mean, they don't have as many short haul flights. They don't have as many problems with this. And the predictions that we're not going to be able to see the stars by 2050 because of the increase in global aviation, that, I used to say that all the time because it was a BBC article, but at the same time, that also means that there will be no change in technology between now and 2050, which you cannot realistically say, especially with the advent of AI and all the new technologies that could solve some of these problems.
Well, that's
So
a
we
little
don't
bit
know.
like
Go ahead.
that's a little bit like Al Gore saying that by 2014 there would be no ice left, etc. So it's like they just keep changing the goalposts, whatever supports
Yeah.
the narrative. And yeah, we should just be leaving it alone, really. If anything is going to block out the stars, it's going to be all the satellites. I mean, that's crazy how many are up there.
That's an excellent point. Although the further you get out, the more room there is. So that's going to be kind of tough. But I mean, I did see Wall-E, so I could see that possibly happening. Come on, am I the only person to watch Wall-E?
Yep.
Yep.
You got kids.
It's a great Pixar film. Don't be a dick, God. Leave me hanging like that.
Like, where's Wally?
No,
Anyway,
it's Wall-E. Go watch it. Shh.
have you got anything else that you wanted to bring, Jeff?
I think we touched on everything. Probably it's 10 o'clock, 9 o'clock,
Almost midnight on the
midnight,
East Coast.
East Coast. Yeah. It's like I could do more. If anybody has more questions, I'm good.
No, Jeff, it's past your bedtime, dude. We know. I've got church in the morning. Oh, here we go. These are my favorite comments. Crab a whiskey. Jim got paid off, so he changed his mind. Bank check payable to Jim Lee at 25 Trip Drive, Sumter, South Carolina, 29153. If I'm gonna be a shill, I damn well better get paid for it. So you mother effers in chat need to come off some checks because this paid off shill over here, and I got my agent haircut in case you didn't catch that today. Got my nice FBI, CIA, Intel agent haircut today.
Government issue.
Yeah, government issued haircut today because I am a shill, and that means that you guys have to pay me. If I'm going to shill for you and stream this shit, you need to pay me. And while you're at it, you need to pay Bettina because she's hosting the call. And then you need to pay Stella and Jeff. And while we're at it, Jay, you need to pay him because if it weren't for him, I wouldn't even be saying contrails right now. So you better I need checks, blank checks with lots of names on them now. 25 Trip Drive, Sumter, South Carolina, 29153. I take PayPal. I won't share with them.
Hey, Jeff. Hey, Jim.
Yes, sir.
Jim, your friend Florida Skywatcher was complaining today. He said he's lost tens of thousands of dollars because Facebook demonetized him. He's been raking in money.
Yeah, he got his monetization back today. He texted me just a little while ago.
He's not given much value for that, though.
I told him he's getting screwed over. Because if you're getting 15 million views on Facebook, and I'm not gonna say the number because that would be,
He put that out. He showed 15.
yeah, I mean, he showed the numbers, but I don't know that he showed the amount that he got paid.
No, he didn't show the number.
But
he did say it in a video.
I told him, I said, dude, if you're doing those kinds of numbers on YouTube, you're talking like $11,000 checks, $20,000 checks per month. So just from me to you, if you're gonna do this as a business, you need to take your ass and stop uploading videos to Facebook, upload them to YouTube, and then monetize that and then share the YouTube video to your Facebook because you're doing it completely wrong. And he was like, "You're kidding me, like that much?" I was like, "Yeah, Facebook is screwing you over." And for all of the people that are out there trying to make a living, thinking that, you know, you're going to do all of this on you know, some social media platform. The reason why I have three, well, technically four, but I don't count Substack because I don't own it. I have three websites because they can never take that away from me. They can never take that away from me. Oh, she'll getting paid. Super chat from Kramos. Kramos, my brother down in Chile, part of the ClimateViewer team, ClimateViewer gang in Telegram chat. I appreciate you, Kramos. And I do owe you an interview. Kramos, by the way, actually took several of my PowerPoint presentations and translated them to Spanish. So he's doing his part to educate the Spanish speaking world. And I'm really grateful to that. I don't know what 5,000 CLP is. I'm not a mathematician, but I appreciate the super chat, brother.
Love you, Grimace.
Yeah, he's good people. So for those who don't know about ClimateViewer Gang, you know, connect.climateviewer.com is the easiest way to get to it, but t.me/climateviewer chat. We're on Telegram all the time. You can come meet the crowd. You can come call us shield to our face. We're going to make fun of you. And then we're going to say, show your proofs. And you know, you're gonna have to come hard or go home. And no punches are pulled in there. And I mean, honestly, y'all have been pretty gentle. Like we had Tony coming pretty hot and heavy today, and I came in and I turned on Telegram. It was like 74 updates in general chat. Damn. And it was it was Jay up there, you know. Hi, I should have introduced myself before diving in head first, and Tony. And I'm like going, I got to catch up on all of this. Damn it, you people are making my life hard. But absolutely phenomenal conversations in Telegram chat, and I could not be blessed with better people around me. It's a blessing in disguise that I had 6,000 members on Discord chat, and then I got banned for saying some stuff about COVID. And now you know, I rebooted with Telegram, and I found all these beautiful people as a result. So I absolutely love, you know, my chat admins, especially, you know, Ed, Jeff, Stella, Bettina. You guys, Bettina's the band hammer by the net. Don't let that sweet face, like, you know, fool you. You come in there, I'm telling you, come in my chat, fuck around and find out. Bettina is the band hammer.
She gonna set that dachshund onto you.
Yeah, that's right. By the way,
love it.
I put the results in the chat here on the Zoom chat of our poll. So our quiz, it's in there, so you can pull it up.
We'll make fun of each other. Excellent.
Yeah, that's right. Okay, guys, we are into 3 hours now. I had lots of fun. I don't know about you, but I had really a good time. Jeff, this was incredible education. Again, I'm so honored and humbled and honored and whatever you want to call it to know you. I came across you in my journey here and geoengineering journey. And yeah, so anyway, I would like to thank everybody for joining in tonight. And I think, like I say, I had lots of fun, and we do that again. Different topic, I don't know, sometime soon, I hope. Yeah, ClimateViewer Gang, love you guys. And it's like what you said, Jim. We have really good people in our chat, and we have really good stuff that people drop in there, and I'm very grateful to be part of it. Thank you so much. Okay, you guys, you have a good night. It's 9 o'clock my time. It's still good, but it's 12 o'clock your time, Jim, I believe. And so, and I think we should wrap it up for tonight. and say goodbye to everybody and see you guys soon again.
Thanks, Bettina.
Thank
night.
you.
Thank you,
Thank you.
Bettina.
Good
Yeah,
night.
thanks
Fun.
for hosting, Bettina. And
Absolutely.
thanks,
Thank
Jess, for
you.
the educations.
Yes,
Anytime.
anytime.
I still need
Exactly.
that personal training because I got to be better than these people. You know that, right?
You know where to find me.
Yeah,
I will catch you during a work day.
for sure.
Okay.
All right,
Good night.
guys. Love you, mean
See
it.
you
Good
guys.
night.